थोड़ा पीछे चलता है क्या ये? Hello, students. Hi. Hi, Srija. Hi, Kenavan. Good evening. Good evening. I hope all of you are doing well and you are preparing well for your NEET examination. So I hope that you all are very much aware that in this session, what we are going to do, we are going to discuss some of the most common, most important, right, question for your NEET examination. And one thing, let me clear this at the start of the session only, that in this session, I will be discussing questions of physical chemistry, right? Physical chemistry of the full class 11th and class 12th, right? And very soon, like within 1 or 2 days, you will have another marathon session for the organic and inorganic part of your class 11th and 12th, right? So let's begin and let's directly jump into the discussion part, right? The question part. And of course, as I told you that in this session, I will be discussing about the physical chemistry, whether it is of class 11th or class 12th, right? So I will discuss questions from the mole concept chapter, atomic structure chapter, thermodynamics, chemical equilibrium, ionic equilibrium, then redox reaction. Then of course, from your class 12th, you have solution chapter, chemical kinetics and electrochemistry, right? So questions from all of these chapters we are going to discuss. So the very first question we have, right? And of course, like when you solve question, so please make it a habit, because when you are going to give your NEET examination, so there will be a total of 45 questions for you. But in your examination, they will not tell you that which question is from which chapter. So my point is, whenever you solve a question, so apart from solving the question, right, try to identify the chapter and topic. See, according to me, what is my point of view, for any question, if you are able to identify that from which chapter that question is, and if you are able to identify that from which topic you got that question, then automatically your brain will recall all those points which you have studied regarding that point, that concept, and then you can solve the question easily. So can you all solve this question, right? Of course, this is a question from a mole concept. Cortisone is a molecular substance containing 21 atoms of carbon per molecule. The mass percentage of carbon in cortisone is 69.98%. Then what will be the molar mass of that molecule, right? So, because it's a moderate type of question, so I will give you 60 seconds, because you have to do the calculation, right, to give your answer. So please start solving, all of you. Of course, later on, I will solve the questions too for you. But first, it will be your turn and then my. So very basic question of mole concept, you can say, right? You have got here. I hope the options are visible to you. Option A 176.5, option B 252.2, option C 287.6, option D 360.1. Done. And see, whenever you attend any session or whenever you see any videos and all, so always keep your pen, paper with you, because you will have to do calculations, because it's physical chemistry. Okay, some of you are saying that it will be option C. So now let's check the answer, right? Let's check the answer. The answer is, of course, D here. And some of you gave the answer C, but of course, that's not correct. So let me tell you that for this question, the correct answer is, of course, D. The correct answer is D. And if you try to solve it, you can do it in a very easy way. So first, let's see that what concept we can use in this question. So in your mole concept, you talk about molecular mass, you talk about percentage composition and all, right? But from my point of view, this question you can easily solve with help of law of definite proportion. You know that law of definite proportion, right? That whenever you take a compound, whenever you take a molecule, so in that molecule, in that compound, right, the ratio of mass always remains constant. So whenever you get a question like this, in which certain things are given for a molecule and certain things you have to calculate for a molecule, whether it is number of atom, like whether it is atomic mass, molar mass, whether it is percentage mass and all. So whenever you get that type of question about any molecular compound, so please use LODP. That means law of definite proportion. Like in this case, they are saying that we have a molecule, cortisone, right? And it contains 21 atoms of carbon, right, per molecule. So point is, if I take one molecule, so in one molecule, there are total 21 atoms of carbon. So the mass of 21 atoms of carbon in terms of AMU, right, in terms of unified mass, it will be 21 into 12, because you all know that the mass of one carbon atom is 12. Mass of one carbon atom is 12, right? So mass of 21 carbon atom will be 21 into 12. So that is the total mass of carbon you have in your molecule, right? Now, they are saying that the mass percentage of carbon in the same compound is 69.98%. So mass of carbon we have in terms of AMU. In terms of AMU, it is 21 into 12. And for the same carbon, the mass we have in terms of percentage, right? In terms of percentage, the mass of carbon is 69.98%. Now, point is, whether you take your mass ratio in terms of AMU or in terms of gram or in terms of percentage, right? The mass ratios should be same, right? So I'm saying that I have carbon, I have the molecule, right? So mass of carbon upon mass of the whole molecule will be same whether you calculate that in the units of AMU or in the units of gram or in percentage, right? So what I'm doing, I'm just comparing the mass of carbon with mass of molecule. Mass of carbon with mass of molecule. Now, mass of carbon in terms of percentage, I have 69.98, right? So the mass of a whole molecule in terms of percentage, it will be 100, right? The total molecule will be 100%, and carbon is out of 100, we have 69.98. And for the same carbon and molecule, if I calculate the mass in terms of AMU, right? So in terms of AMU, mass of carbon is 21 into 12 AMU, and in terms of AMU, if you calculate the mass of molecule, so that is nothing but the molecular mass, and that's what you have to calculate, right? You know that magnitude of molar mass and molecular mass remain same, right? So if I assume that the magnitude of molar mass or molecular mass of compound is x, so I can write it x here, and both will be equal according to law of definite proportion. So what I did in this question? Nothing. I just equated the ratio, right? Ratio of mass of carbon to that of the whole molecule. In terms of percentage, it is 69.98 upon 100, and in terms of AMU, it is 21 into 12 upon x. Now from here, if you calculate x, so that will come out 21 into 12 into 100, right, cross multiplied, divided by 69.98. And if you solve it, right, definitely you will get your answer. So now some of you are saying that answer is D, right? Shreyanshi, absolutely correct, right? But see, my point is, with each and every question, try to gain some concept, right? After doing this question, now you should be able to do those questions in which there is a molecule, there is a compound, right? And for that molecule, for any particular atom, its atomic mass is given, molecular mass you have to calculate, or for some atom, mass percentage is given, and for the whole molecule, the molecular mass you have to calculate. So anything related to atomic mass, molecular mass, right? You can solve in terms of LODP. And the most important takeaway from this question is, in any compound, let me write it for you once, then we can move into the next question. Let me write it for you. Point is, you take any molecule. I am taking H2SO4 because this is very common, very simple. For any molecule, right? For any part, whether it is hydrogen, sulfur, oxygen, or whether it is the whole molecule, for any part, when you compare the mass ratios in different units like gram, AMU, percent, so their ratios will be same, right? Ratio in terms of gram, AMU, and percent will be always equal, right? So that means suppose I take the mass of hydrogen in H2SO4, right, in terms of AMU, and I compare that with the mass of whole H2SO4. So mass of hydrogen in AMU divided by mass of H2SO4 in AMU will be equals to, right, mass of hydrogen in gram upon mass of H2SO4 in gram will be equals to mass percent of hydrogen upon the full percentage of the molecule, which is 100, right? And you can do the comparison for any part. I can do like this also. In H2SO4, I have some X gram of SO4. In H2SO4, I have X gram of SO4, right? So, mass of SO4 in gram divided by mass of H2SO4 in gram will be equals to mass of SO4 in AMU upon mass of H2SO4 in AMU. So point is, mass ratios will be equal whether you calculate the ratio in terms of gram, AMU, and percentage. Please remember that. And from that point, you can solve any of the questions of this type. This type of problem you can easily do. And if you see NEET PYQ, so in NEET PYQ also, previous year questions also, you will find these types of problem, right? So with this, now, can I go to the next question now? I hope so. And from this question, we understood law of definite proportion. So let's move on to the next question now. Yeah, can you do it? If you read the question carefully, so of course, this question is again from the same chapter, that is mole concept, right? And this time, your topic is empirical formula, calculation of empirical formula. So you know that calculation of empirical formula and molecular formula is an important topic for you, right? Now, use your pen, paper and brain. Use your pen, paper and brain and try to solve this question. And I'm giving you a little bit of extra time in this. So let me give you "90 seconds. Yeah, solve it. Of course, I will also tell you the concept behind this, but I think empirical formula, all of you can solve. The questions of calculation of empirical formula, all of you can do. Some of you are saying A. And please do the calculation faster, because in your exam also, You will have to be quick. Increase your speed, increase your accuracy. So some of you are saying that answer is A. So let's check that what is the correct answer here. Shreyanshi said D. I think Shreyanshi, that's for the previous question, right? D. Okay. Of course, the answer was A. Now let's check how many of you have given the right answer. Okay, so whoever answered right, that was the correct answer. So for this question of empirical formula, the right answer is A, right? Now, if you talk about calculation of empirical formula, I think that's a very easy point, right? First of all, see that in your compound, what elements are there? Like whatever compound we have, certain alkaloid. So it has carbon, then it has hydrogen, then it has nitrogen, right? And also apart from carbon, hydrogen, nitrogen, it has oxygen. So 4 elements are there in your compound. So first of all, write down which elements are present in the compound. Now, along with the element, they have also given what is the mass percentage, right? So for carbon, clearly the mass percentage is 70.8. For hydrogen, the mass percentage is 6.2. For nitrogen, the mass percentage is 4.1, right? And for oxygen, they have not given because you can calculate that, right? The total mass percentage will be 100, right? So 70.8 plus 6.2 plus 4.1 if you do, so 8 plus 2, 10, 10 plus 1, 11.1, 617, 4, 11, and 7 plus 1, 8. So these three together, they are 81.1%. Now because the total mass percentage is 100, so if I calculate for oxygen, it should be 100 minus 81.1, right? And that will be 10 minus 10 minus 1, 9, right? So it will be 18.9%, right? So oxygen is 18.9 percentage, correct? So now we got the mass percentage, and whenever you will be getting question of empirical formula, you know very well that they will always give you the mass percent, or sometimes they can give you the mass in terms of gram. So do not worry whether it is given in gram, whether it is given in percentage, right? In both the cases, you have to apply the same technique, and the technique is try to get number of moles, try to get number of moles of the atom, right? So as you know that for carbon, the atomic mass is 12, and if its mass percent is 70.8, then if I calculate number of moles of carbon here, so number of moles of carbon will be 70.8 divided by 12, right? Similarly, if I calculate number of moles of hydrogen, so that will be 6.2 divided by atomic mass of hydrogen, which is 1, right? And for nitrogen, 4.1 divided by atomic mass of nitrogen, you know that it is 14, right? And for oxygen, the mass percentage is 18.9 and its atomic mass is 16. So once you calculate the mole, right, just round it off, right, or multiply with suitable number to convert them into integer, right? And once you get the simplest whole number ratio, you will be getting your empirical formula. So basically, from mass percent, we always calculate moles, number of moles. And the simplest ratio of this number of moles gives us what? Empirical formula. So if I calculate this, round off, so 70.8 upon 12 will be 12 5s are 60, right? And 12 9s are 108. This is 6.2. This is 4.1 upon 14. That means 0.2. Round off 9. 18.9 upon 6 is 16 ones are 16. Remaining 2. Roughly 1.2. So point is we got number of moles, but they are not in the integer. They are in fraction. So to convert these fractional values into integer, first point is try to round it off, right? Up to 0.1 you can do round off. Up to 0.1 plus minus 0.1 you can do. Like if it is 5.9, you can keep that 6, right? If it is 5.05, you can keep that 5. But here, you cannot round off this 0.29 or 6.2 or 1.2, right? So for here, to convert this into integer, what is the first step? I hope you know. The first step is divide each number with the smallest value, right? So out of 5.9, 6.2, 0.29, 1.2, the smallest value is 0.29. So if I divide each value by 0.29, right, I can get my answer. I can get my answer, right? Here you don't have to do any kind of round off here. As soon as you divide by 0.29, you will get approximately your answer, and that will be A. Means when you divide this 5.9 by 0.29, you will be getting 20, and for hydrogen you will be getting 21. For nitrogen, of course, 0.29 by 0.29 will be 1, and for oxygen, it will be round of 4, right? So that's how you calculate the empirical formula. Mass percentage or mass will be given, divide by atomic mass, get the mole, and convert the mole values in the simplest whole number ratio, right? And that simplest whole number ratio will be your empirical formula, correct? So definitely in this case, our answer was A, C20, H21, N1 and O4. So can we go to the next question now, all of you? I hope I am audible and I am visible. Tell me in the chat box, am I audible? Yes? No? Okay. The next question you have. Can you do this quickly, all of you? In which of the following pairs 1 gram of each have equal number of molecules? So again, a question from mole concept, and in mole concept, apart from empirical molecular formula, you have a very standard topic, right, known as calculation of number of atom or number of molecule. From that also you get questions in your NEET examination. So what I have tried in this session, I have tried to keep those questions which are quite similar, quite closer to your NEET examination. So I hope that this question you can answer. Why I'm not getting poll? Let me start it. I hope that now you must have got the poll. Tameshwari. Someone answered C for this question. Keep going, keep going. I think the poll, as soon as I start the poll, like currently I have started it, you can see that on your screen. I hope so. Srija, Priya, Canavan. Okay, this time most of you are giving the answer C. So I think this question is direct, right? You don't have to do much calculation in it, correct? So now let's check what should be the correct answer, right? And I think most of you have already done that. In this question, the correct answer will be none other than C, right? So some of you gave the answer, of course, and it is absolutely correct. And this question was very basic, right? In which of the following pairs do 1 gram? So 1 gram is your amount here, right? 1 gram of each have equal number of molecules. So you know that number of molecule can be calculated as number of moles into Avogadro number. And later on, after number of molecule, if you try to calculate number of atom, so number of atom is calculated by number of molecule into atomicity. Atomicity is number of atoms per molecule. But in this case, we have to just calculate number of molecules. So number of molecule will be number of moles into Na. Now they are asking, in which case, if I take 1 gram each, the number of molecules will be equal. So obviously, right, when I calculate number of molecule for two compounds, if number of moles are same, if two compounds have same number of moles, right, then Avogadro number is common for both. So same number of moles if they have, that means then they will have same number of molecules, right? So when two compounds will have same number of moles, if they have equal mass, obviously when they have same molar mass. So in this question, we have to just figure it out that in which option the molecules have same molar mass, right? Like in the first option, if you notice, you have N2O, right? So for N2O, the molar mass will be, so for 2 nitrogen it is 28 and for oxygen it is 16. So 28 plus 16 it will be 44, and for CO, carbon's atomic mass is 12 and for oxygen it is 16. So 12 plus 16 it will be 28. So clearly in the first option, N2O CO, they do not have the same molar mass, and if they do not have same molar mass, they will not have the same mole for same mass, right? And I hope you know that basic point very well, that when I calculate number of mole, so that is given mass upon molar mass, right? So because they have same mass, 1 gram, so just by comparing molar mass, I can find that which one have same number of mole. Similarly, if you compare N2 and C3O2, C3O2 is very famous, right? Carbon suboxide. You may have seen C3O2 in your redox reaction chapter, right? While calculating oxidation number. So for N2, the mass is 28, the molar mass is 28, and for C3O2, for 3 carbon, it will be 36, 12 into 3, and for 2 oxygen it will be 32. So 36 plus 32 it will be 68. Of course they are not same, right? So in B case also they will not have the same number of molecules, same number of mole. But in option C, N2 and CO we have, right? So for N2, just now we calculated, for N2 molar mass is 28, and for CO, here we calculated, for this also molar mass is 28. So because N2 and CO have same molar mass, so for 1 gram, if I calculate number of mole, so for N2 it will be 1 upon 28, for CO it will be 1 upon 28, right? So they have same number of mole, so automatically they will have same number of molecules. So definitely in this case, your answer should be C. Yes, it is C, correct? And I saw that in the chat, most of you did it, right? Correctly. So well done, all of you. And after this, and see, here by looking at each and every question, you can also evaluate that in which topic you have to focus more. Like suppose if you did this question, if you calculated number of molecule easily, so that means what? You don't have to revise this topic much. Focus on those topics in which you feel that you are weak, you are not able to calculate, you are not able to solve the question. So with this, now let's move on to the next question. Can you all do it? Yeah, again we have a question from mole concept only. So I have kept questions chapter wise, but topic you will have to decide by your own. Let me start the poll, and I hope that you people are doing it. If I check the calculation, it's not very much. It's an easy calculation here, because in stoichiometry, you need some time when your question is in terms of gram or other units. But when the question is in terms of mole and the answer is in terms of mole, the calculation is very easy. So please do it quickly, and I will give you just 45 seconds for this. Mark your answers, all of you. Which one is right? A, B, C, D. And I hope that poll is visible to all of you. All of you can see the poll. Subodh gave right answer for the last question. Priya answered C. Subodh answered C. Well done, guys. Keep going. So by looking at the chat, I can understand that you people are very good in some of the topics like stoichiometry especially. Of course, stoichiometry is famous. Some of us, sometimes we name this chapter like stoichiometry. We do not call it mole concept. Instead of that, we call it stoichiometry. Okay, so now let's check the answer. Many of you gave correct answer this time. And of course, your answer is C. Right, Srija? It is C. It is C. None of you gave wrong this time. That's the good thing. Let me check leaderboard once. So Priya gave answer in 17 seconds. I think some of you are even quicker than me, right? I take a little bit of time in calculation, right? Subodh, very good. Kanvan, Srija, very nice. So now let's solve this. Although you know that it's a very much doable question. Point is, this is a question of mole concept chapter from the topic stoichiometry. Now, whenever I talk about stoichiometry, my mind automatically recalls certain points. Points like I should have a balanced equation, because that's the first mandatory thing you should have, right? Balanced chemical equation. Then my mind recalls about limiting reagent, percentage yield, right? Excess reagent, right? Efficiency of the reaction. So these are the topics from which you get question in your examination. But this time the question is pretty much simpler. They have given the equation and it is already balanced. 2p plus q gives r. Now they are saying that if I take 8 moles of p, means I am taking the reactant 8 moles of p, and I have excess of q. So already they are saying that q is excess. So if q is in excess amount, then automatically p is your limiting reagent here. P is your limiting reagent here. So what will be the amount of product, right? So you know very well that out of 2 or 3 reactants, whenever one reactant is limiting reagent, right? So calculation of amount of product, how much product you are getting, so that is calculated always on the basis of limiting reagent, right? And here your limiting reagent, you already know it is P. Now, point is, how to apply stoichiometry? You know very well that in a balanced equation, the coefficients, the stoichiometric coefficients are nothing but molar ratios. Means here, I can say that 2 mole of P will completely react with 1 mole of Q to produce 1 mole of R, right? And this ratio will be always fixed, just like law of definite proportion. And I hope you know very well that stoichiometry, the base behind stoichiometry is LODP, law of definite proportion, right? So 2 mole of P will produce 1 mole of R. So you can use unitary method. You can say that 8 mole of P will produce 4 mole of R. And I have seen that some students, although unitary method is a very easy topic, right? You learn that in your 4th, 5th class. But still some students, they face issues, they face problem in applying unitary method, right? So for them, what you can do, this is 2 mole, this is 1 mole. This is your fixed ratio according to stoichiometry. This, you know, it is 8 mole. Now you have to find the amount of R. So what you can do, assume that R is X mole, right? R is X mole, and just equate the ratio, because this stoichiometric ratio should be fixed, right? So amount of P and Q in terms of mole, it is 2:1. So 2:1. It should be equals to this ratio. That means 8 and X. So 8 by X. So like this also you can do your calculation. X will be how much? 4 mole. And 4 mole is nothing but C. And many of you did that. So let me quickly show you the answer. Of course, it is C. And let's move ahead, right? Because we don't have to talk much in the stoichiometry. Now, can you do this one? Equal weight of X, the atomic weight of X is given 36, and Y, the atomic weight of Y is given 24, are reacted to form the compound X2Y3. So this time you will have to write your equation, right, from your side. So use your pen, write the equation, write the balanced equation. And if I take equal weight of X and Y, so here you don't have to calculate the product. You will have to answer that which one is limiting reagent or whether you have limiting reagent in this or not, correct? So let me start the poll. Some of you have already started giving the answer. Very nice. How much time I can give? I should give 60 seconds because for limiting reagent you need to do some calculation. So please give your answers, all of you. Priya already gave the answer B. Well done, Priya. Subodh gave the answer D. Nice. Kenavan gave C. Priya B. Shadow Gaming C. Okay. It's a very interesting question because few students, they don't know, like in what case we say that there is a no limiting reagent. In what case we say that there is a no limiting reagent in your reaction, right? So let's end the poll and let's see how many of you have given the right answer in this. Correct? So 25% means, of course, some of you gave the right answer, like Subodh gave the right answer. Well done. And some of you gave B. B means Y is the limiting reagent. And C, 50% of you gave C. Both are limiting reagent. Okay, we need some clarification here. So once let's see the leaderboard. Subodh only gave the right answer in 20 seconds. Okay. Before I begin into the calculation, please try to understand one thing, that in any reaction, if there are two reactants and both are getting completely consumed, then we say that we do not have any limiting reagent. So option C can never be true. Please remember that. Both are limiting reagent is not possible. If two reactants are there and both are getting completely consumed, then we say that there is no limiting reagent in this, right? None of them is limiting reagent. You can't say that both are limiting reagent. So C is never possible for any question, right? Now in this question, if you write down the balanced equation, so you can write it like this, 2x by looking at the formula, because we have to prepare x2, y3, x2, y3. So I can say that 2x plus 3y will react to produce x2, y3. So I got my balanced equation. Now according to this equation, 2 moles of x can react with 3 moles of y. 2 moles of x can react with 3 moles of y. Done. So this is my fixed ratio. You know that it is always fixed. 2 mole, 3 mole. Now they are saying we have to assume equal weight. Let's say that this is W gram. So this is also W gram. If x is W gram, then y is also W gram. Now because they have mentioned amount in terms of gram, so I need my ratio in gram. So from mole ratio, you can easily convert that into gram just by multiplying with molar mass or atomic mass, right? So for x, if it is 2 mole, and for x the atomic weight is 36, then 2 into 36, which will be, I think, 72. In gram, it will become 72 gram. And we have 3 moles of y. So for y, the atomic weight is 34. So 3 into 24, it will be also 72 gram. So point is, in this reaction, right, they are combining in terms of mole as 2 mole and 3 mole. That's the ratio. And in terms of gram, it is 72 gram and 72 gram. Means both are getting consumed in equal mass, right? Now, you know the trick to calculate limiting reagent, students, right? Whatever given amount you have, divide that by fixed ratio. So this is a fixed ratio in terms of mole, and this is a fixed ratio in terms of gram. If they have given amount in mole unit, use the mole ratio. If they have given the amount in gram unit, then use the gram ratio to find out limiting reagent. How? Just divide. The given mass is W gram. So if I divide W by 72, so we need not to solve this. It will be W by 72. And if I do it here, so for Y it is W gram, and according to the fixed ratio, it should be 72. So just calculate that. Given amount upon the amount in fixed ratio. Given amount upon amount in the fixed ratio. And the one whose value is smaller is your limiting reagent. But point is, in this case, W by 72, W by 72 both are equal. That means what? If both are equal, none of them is giving you the smaller value. That means here both will be getting consumed completely. And if both are getting consumed completely, then you say that there is a no limiting reagent. So in this question, the answer will be not A, not B, not C, it will be D. None of them will be the limiting reagent, right? And from the ratio itself, you can understand that 72 gram will react with 72 gram. So W gram will completely react with W gram. So both of them will be consumed. And if both of them is consumed, then none of them is limiting reagent. So answer will be definitely D here, right? Subodh gave the right answer. And I hope that rest of you have understood that when both the reactants are consumed, then we say that there is a no limiting reagent, right? Right, Priya? Kenavan, Shadow Gaming, Aquarius, okay, C60, C60. I hope you know C60 is the allotrope of carbon, right? Okay, let's move ahead. We don't have to stop. We have to solve, you know that, questions from each chapter of the physical chemistry, right? So can you do this one? Again, we have a question from the mole concept, but this time from the different topic. What is the quantity of water that should be added to 16 gram methanol? I hope you people know from your organic chemistry that molecular formula of methanol is CH3OH, right? To make the mole fraction is a concentration term. Okay. Is 0.25. So I hope you know very well that we have a topic called concentration term in mole concept chapter, where do you do the calculation of molarity, molality, mole fraction, normality, parts per million, parts per billion, mass percent, volume percent, right? Mass by volume percent, and you do the interconversion also, right? That's the important topic, right? Converting one one concentration term into another, right? If molarity is given, find molality. If molality is given, find mole fraction. If mole fraction is given, find molarity. So those types of questions are also important. So in concentration terms, in NEET, we get mostly two type of question. Either direct means direct calculation, direct formula based, or the conversion of concentration terms, right? So let me start the poll and let's check how many of you can do this one. Subodh gave the answer, Priya gave the answer. Kanavan, Priya, nice. Full syllabus, let's see whether we will be able to do it today or not. But Marinan, what I plan that we can break this in two sessions, right? In one we can do the physical, and in one we can combine the organic and inorganic, right? No, for NEET exam, NETU 1150. These questions are like quite similar to your NEET exam. Yes, today I am discussing the whole physical chemistry of class 11th plus class 12th? So now let's see how many of you have given the right answer in this. Although it's a direct question of formula, mole fraction. Okay, Aditya. The correct answer is absolutely A, right? And Subodh gave the right answer immediately. Then Priya, Kanavan, Srija, well done. So you know that it's a pretty much easy question for you. Like if you know the formula of mole fraction, you can solve it, right? What is the formula of mole fraction of any component? Like here we are calculating the mole fraction for methanol, let's say. So for methanol, it will be moles of methanol divided by moles of methanol plus moles of solvent. In this case, what is your solvent? Solvent is water. So you can say moles of methanol plus moles of water, right? Now, question is, they have given the mole fraction of methanol already. It is 0.25. So substitute the value. Mole fraction of methanol is 0.25 equals to, we have 16 gram of methanol. For methanol, 1 carbon, 3 hydrogen, 1 oxygen, 1 hydrogen, right? So 12 plus 3, 15 plus 1, 16 plus 16. Its molar mass is 32. And if it is 16 gram, then the number of moles of methanol will be 16 given mass upon 32 molar mass, it is 0.5, right? So number of moles of methanol we have is 0.5. Divided by again number of moles of methanol, it is 0.5 plus, you can calculate number of moles of water here, right? And once you calculate number of moles of water, you know very well that from mole we can convert into gram just by multiplying with molar mass. So the weight of water here will be number of moles of water, which you can get from this equation easily, and multiplied by 18. So I'm not doing the calculation further, but you people will have to, right? You need to do the multiplication like 0.25 into 0.5, which will be 0.125, right? Plus 0.25 into moles of water equals to 0.5. Then you will have to do the subtraction 0.5 minus 0.125, right? And upon 0.25, if you do, then you will be getting number of moles of water. And finally into 18 will give you the mass of water. So this type of question, I say that these are direct problems. Direct problem means you apply the formula of concentration term, you get your answer, right? Molarity, number of moles of solute upon volume of solution in liter, right? Molality, number of moles of solute divided by weight of solvent in kilogram. Mole fraction, number of moles of one component upon number of moles of all components, right? If there are two components, then number of moles of solute plus number of moles of solvent, right? Hi, Shoaib. Yes, Mrinan. So for this question, right, we know that the answer is A because Subodh immediately gave the answer, Priya also, right, Canon also. Now let's move on to the next question. And again, we have a question from the same chapter, mole concept, but this time again from concentration term. Can you do it, all of you? But this time we have a standard problem, right? It's very famous. Like for a solution, if mole fraction is given, you have to find the molality, or vice versa. Sometimes the question is like molality will be given and you will have to find the mole fraction, correct? So please do it. I will give you a little bit of more time in this. So start giving your answers. Okay, Sania. Good evening. I hope it will be better if you give your answers in the poll, right? If it's visible, if the poll you can see, right? So please answer in the poll because then it will help me to collect your answers, and from that I can conclude that in which part I have to discuss, right? Like if there is a question in which suppose all of you are doing it wrong, right? So I need to go into the content of that topic also, that question. Okay, this time many of you said A. So let's see. Subodh, should I stop the timer now? I hope so. Yes, the answer is A. You gave it right in the chat box. I think all of you. I can see that all of you gave it right. And you people calculated it very faster, right? Nice. I hope you are not using calculator in this. Please don't do that. See, whenever we get this type of question, like what I do, means what I prefer, I assume either the weight of solvent 1 kg or the volume of solution 1 liter, depending upon the question. Like in this question, I can see that one of the term is mole fraction and the other term is molality. Now, I know that mole fraction molality, they do not deal with volume, right? They don't have volume in their formula. So in this case, I will not assume volume. I will assume that weight of solvent is 1 kg or 1000 gram. But if I have a similar type of question of conversion of concentration term, and suppose that in that question molarity is there, normality is there. So in those questions, I assume that volume of solution is 1 liter or 1000 ml. Assume this and just apply your formulas, you will get your answer. Blindly, you will get your answer. You don't have to apply much effort in this. So first of all, because they have given the mole fraction 0.2, right? So I should apply the formula of mole fraction. Mole fraction of A will be moles of A upon again moles of A plus moles of water, because water is your solvent. So here mole fraction of A is given 0.2 equals moles of A we do not know, again moles of A we do not know, but moles of water, if I have taken solvent 1000 gram and solvent is water whose molar mass is 18, right? I can easily get the number of moles of solvent, right? Number of moles of solvent will be given mass 1000 upon 18, which is 55.5. So I will take 55.5 here, right? From this, you can calculate what? You can calculate Na, means number of moles of your solute A. And once you got number of moles of solute, you can easily find what? Molality, because molality is number of moles of solute upon weight of solvent, which I already assumed to be 1 kg. So here it will be 1. So point is, if you calculate number of moles of solute here, so that will be directly your molality. So by assuming this point that solvent is 1 kg or 1000 gram, your calculation will become easier, right? So if it's a question related to molarity, mole fraction, assume weight of solvent 1 kg. And if it is a question related to molarity, normality, then assume volume 1 liter, right? You do not have to memorize formulas, right? I hope you know that we have certain formulas here, a direct formula between mole fraction and molality, right? Or direct formula between molarity and molality. So from those formula, if you want to get rid of that, you don't want to memorize that formula, you can apply this technique. One assumption and just apply the fundamental formulas of mole fraction, molality, molarity, whatever involved in your question, right? Hi Surya, I hope you are doing well. So in this question, all of you almost gave the right answer, but please do not use calculator, because I know that in this case, when you do the calculation, it will take a little bit of time. So you can't get immediate answers, right? Now, let's move ahead. So till now, if you notice, right, whatever 7 questions we did, So they were from the first chapter, that means mole concept. Now we are jumping into the second chapter of class 11, that is atomic structure, right? I hope you know that atomic structure, it has three parts, right? In atomic structure, you talk about three parts. You can divide the chapter in three parts: Bohr model, quantum model, and dual nature. In Bohr model, you have calculation of parameters like radius, velocity, energy, angular momentum, then Rydberg equation, spectral lines, right? And then in quantum model, you have electronic configuration, number of orbital, number of orbits, right? Number of subshell, electronic configuration, finding the value of quantum numbers of an electron, nodes, shapes of orbital, right? Graph of psi, right? Psi square, radial probability, right? And in dual nature part, you have photoelectric effect, black body radiation, de Broglie's equation, Heisenberg uncertainty principle. So from all those 3 points, now you will see some questions, correct? So be ready. This question, just by reading the first line, I can say that it is from the photoelectric effect, right? And you need some time. When you get a numerical question from photoelectric effect, you need some time to do the calculation. So please do it. Use your pen paper. I will give you more than 2 minutes in this, right? Priya gave the answer already. Sania gave the answer. Priya, Sania, I hope that you are doing the calculation by your own, right? Surya gave the answer B. Well done. At least you are trying. That's a good thing. Let me read the question first. Electromagnetic radiation of 310 angstrom. Okay, wavelength is given. Subjected to a metal sheet, fine, having work function or threshold energy of 12.8 electron volts. What will be the velocity of photoelectron with maximum kinetic energy? Okay. With pen, paper, and brain. Sania, I always use that term ppb. Although ppb is a concentration term for us, right? Parts per billion. But for me, ppb is pen, paper, and brain. Subodh gave the answer C. Srija C, Canvan C, okay. So there is a conflict in the answers. Some answers are C, some answers are B. Fine. Let's check now. Along with mobile. Of course, mobile you will have to use in the online session. Mobile, laptop, iPad, they are important for you. But when you are doing self-studies, right, that time you don't have to use the phone. Okay, so in this case, of course, the answer is C. And some of you gave it B. No worries, right? See, in photoelectric effect, you have only one formula, one fundamental formula, only one formula, and that you have to memorize. The formula is total incident energy minus threshold energy or work function is equals to the maximum kinetic energy of your ejected electron, right? Electron that is getting ejected due to attack of photon. Now, these energies you can change according to your question. This energy can be written in terms of wavelength, in terms of frequency. So in this question, because they have given the incident wavelength, so this energy I can write it as hc upon lambda, right? Minus E naught. They have directly given, so keep it as it is. And we do not have to find kinetic energy. We have to find what? Velocity. So if I need velocity, I can convert kinetic energy as half m to 10 power 8 upon wavelength in terms of meter. 310 angstrom will be 310 into 10 power minus 10 meter minus your work function or threshold energy is 12.8 electron volt, right? There is a problem. When I calculate this from hc by lambda, I will get the energy in terms of joule, right? And here the threshold energy they have given in terms of electron volt. So for principle of homogeneity, I need the same unit. So what I can do, I can convert electron volt into joule, and that's very easy. Just multiply by 1.6 into 10 to the power minus 19. So that 12.8 electron volt will be 12.8 into 1.6 into 10 to the power minus 19 joules, right? And now this will be equals to half mass of electron, which is nearly 9 into 10 to the power minus 31 kg, right, into V square. So it's a big calculation, but if you solve it, you will get your answer as C. Without Subodh, you used calculator in this, or you did the calculation by your own? I know that we all human beings are lazy in calculation, all of us, but suppose if this question you get in your NEET exam, right? So there you will have to give time in the calculation. So from here, if you calculate, the velocity will be 3.08 into 10 power 6. That's the answer, right? 3.08 into 10 power 6 by own. Well done. Although what I have noticed, like if you check the NEET PYQs, so because, right, I have arranged this question, right? It's not a PYQ. That's why in this question you have a little bit of more calculation here. But normally, if you see the NEET PYQs, so in the examination, they will not give you these many calculation. In examinations, the calculations are simple, right? There will be factors like they will be cancelled easily in your exam, right? So in atomic structure, point is we do get question from this topic, that is photoelectric effect. And along with this question, let me give you a revision here. In photoelectric effect, I hope you know that point, which comes in reasoning question, right? When you increase the incident intensity, right? So with that, the number of ejected electron increases. And if you increase the incident frequency, so with that, the kinetic energy of ejected electron increases, right? And the graph part, right? In photoelectric effect, we have a graph also, right? Like this. This is your threshold frequency, and here is your kinetic energy. So with incident frequency, as frequency increases, the kinetic energy of ejected electron also increases. So this is the overall topic in your in photoelectric effect. Either you get statement-based questions, right, or you get numerical directly from the formula. Now, after photoelectric effect, let's see the next question we have. Can you do this quickly? What is likely to be the principal quantum number for a circular orbit of diameter 20 nanometer of the hydrogen atom if we assume Bohr orbit be the same as represented by the principal quantum number? So if you have studied quantum model, right, you should be knowing this point, that in Bohr model, the principal quantum number we have is nothing but same orbit number, right? In Bohr model, the orbit number we have, the same orbit number we have adopted in quantum model as principal quantum number. So it's a question of Bohr model. And let me start the poll for you. Please give your answer in the poll instead of chat box. Well done, Subodh. Surya said B, Priya said B. Good going, guys. And I think for these two chapters, we have uploaded the one shot also, right? For mole concept and atomic structure. In that one shot, right, you can find all the topics. Yes, Surya, that's the formula for radius. Okay, so let's check the answer now. Of course, in this case, the answer is in chat box. Many of you have given B. So that's the correct answer actually. The correct answer is B, and all of you gave it right. Priya, Surya, very good. You took time. That's good. See, what is likely to be principal quantum number means we have to find the orbit number, basically. We have to find what is the orbit number, right? For that orbit, whose diameter is 20 nanometer, if diameter is 20 nanometer, that means radius will be how much? Half of this, 10 nanometer, right? Of hydrogen atom. So hydrogen atom is there, so its atomic number will be 1, right? If I assume Bohr model, okay. Now, in Bohr model, you know that radius is given as 0.529 into n square upon z angstrom, right? And if it is 10 nanometer, so can we convert this nanometer into angstrom, all of you? So both how we convert nanometer into angstrom? By multiplying or dividing with? Ten, right? So it can be 100 angstrom. 10 nanometer means it will be 100 angstrom, correct? So my radius is 100 angstrom. It is 0.529 into n square. I have to calculate, and z, because it is hydrogen atom, so for hydrogen atom the value of z will be 1. So from here, if you calculate n square, so n square will be 100 divided by 0.529, correct? And finally, if you calculate n, so you will have to do a little bit of calculation, under root of 100 upon 0.529, right? And if you calculate, the answer will be not exactly equals to 14 in this case, but nearly it will be 14, right? So both, is it coming exactly 14? I don't think so. It will be round off equals to 14. Who is this shadow? Multiplying. Okay. So of course, in this case, answer is 14. But what is the takeaway from this question? Yeah, it is nearly 13.5, but round off near about, we can say that it will be 14. What is the takeaway from this question? That you should remember the formulas in Bohr model directly. It should directly strike in your brain. Radius 0.529 into n square by z angstrom. Energy minus 13.6 z square by n square, right? Electron volt. Velocity 2.18 into 10 power 6 z by n meter per second. Angular momentum mvr equals to nh by 2 pi. Yeah, that's what I was saying, that it will not be exactly 14, it will be roughly 13.8 or 13.7. Okay, Shreyanshi. So for this question, of course, we got the answer, it is 14. So now let's move ahead. After this Bohr model in our atomic structure, let's see what is our next question. So next question is again from Bohr model, but from the hydrogen spectrum part, right? You know about transition of electron, right? Second orbit to first orbit, third orbit to first orbit, Lyman series, Palmer series. So question is, the shortest wavelength of helium plus in Balmer series is X. Then the longest wavelength in the Paschen series of lithium plus 2 is, right? Here you need to apply, Rydberg equation, right? 1 by lambda equals rz square 1 by n1 square minus 1 by n2 square, where n1 is the inner orbit and n2 is the outer orbit, correct? So please do the calculation, take your time, but give me the right answers, all of you. Shreyanshi gave the answer. Sanya, Kenavan, Subodh. Subodh's answer is different. Priya, Surya, well done. I hope you people understands what is the meaning of shortest wavelength and longest wavelength. When you say shortest wavelength, that means highest energy, radiation of highest energy. And when you say longest wavelength, so that means radiation of lowest amount of energy in any series. Srija gave B. I can see that many of you have given it right, correct? So let's see how many of you have given the correct answer. Oh, 50-50. Some of you gave A, some of you gave B. Fine. So let's first go into the concept part. So point is they are saying shortest wavelength of helium plus in Balmer series, right, is X. So pause here. When you say Balmer series, so Balmer series means any transition, right, where your electron finally jumps into n equals to 2, right? So for Balmer series, always n1 is 2, correct? Now n2 here will be decided from this. They are saying shortest wavelength, that means highest energy should be radiated because energy and wavelength for a wave is inversely proportional. Now in Balmer series, highest energy will be radiated when you will have transition from infinity, right? So here the transition should be from infinity to 2, right? So if n1 I am taking 2, n2 I will have to take infinity, correct? And our ion is helium plus. So can we apply Rydberg equation for this case, for this transition? Of course we can. 1 upon lambda, 1 upon wavelength, where wavelength is x, so I can take it x directly. So 1 upon x equals r z square. For helium, z is 2. You know that very well. So z square will be how much? 4. Right? Into 1 upon n1 square means 1 upon 2 square will be 1 upon 4 minus 1 upon infinity square is infinity. And in chemistry, 1 upon infinity we take as 0. So from here I can say 1 upon x will be equals to r into 4 and 1 by 4 is there, 1 by infinity is 0. These 4 will be cancelled. So from here we are getting this relation that 1 by x is equals to r. So I will use that in the next transition. I can put r as 1 by x. Now in the next transition what we have? Now we have the lithium ion, right? Li2 plus. And for lithium, the atomic number is 3. And here the transition is of Paschen series. Lyman, Balmer, Paschen, right? Now for Paschen series, you know very well that its n1 will be 3, right? When any electron jumps from any state, right, higher than 3, higher than n equals to 3, from 4 to 3, 5 to 3, 6 to 3, infinity to 3, all those transitions are called Paschen series, right? Lyman, Balmer, Paschen. Now here n2 we have to decide according to what wavelength we want. So here we want longest wavelength. Now if I want longest wavelength, then there should be emission of lowest amount of energy, right? And lowest amount of energy will be radiated when your electron will jump from 4 to 3 here in case of Paschen. Now again, for this transition, if you apply the Rydberg equation, you will get your answer. That's what they are asking, right? So here 1 by lambda will be r. So instead of r, I can put 1 by x. Instead of r, I can put now 1 by x into z square. So z square here for lithium 3 square will be 9 into 1 by n1 square. So 1 upon 3 square is 9 and 1 by n2 square, 4 square is 16. So from here, if you calculate, you can get your lambda and that will be B, and many of you gave the right answer. Subodh, currently only online. So of course the answer will be B. But what's the takeaway here? 2-3 points, right? First, you should know the Rydberg equation. 1 by lambda equals rz square 1 by n1 square minus 1 by n2 square. And secondly, you should know what is the meaning of Lyman series, Balmer series, Paschen series, Brackett series, Pfund series, Humphrey series, and what is the meaning of longest wavelength, shortest wavelength, right? Limiting line, starting line in your hydrogen spectrum. Limiting line means infinity to n. For Lyman, it is infinity to 1. So those things, if you know, you can solve these types of questions, correct? And for this, the answer is B. So let's move ahead in the atomic structure chapter. And now let's see one more question. But this time, now it is not from Bohr model. I told you we have 3 parts in this chapter: Bohr model, dual nature, and quantum model. So this time we have a question from dual nature part. Can you all do this quickly? In a hydrogen atom, if x is the radius, of first Bohr orbit, x is your radius of first Bohr orbit, means n equals to 1. de Broglie wavelength of an electron in third orbit. So we have to find de Broglie wavelength of any particle is calculated by h upon mv or h upon under root of 2 into mass into kinetic energy, right? So for third orbit, we have to calculate. Do the calculation. I think you don't need much time here. Give your answers, all of you. Fast. And let me tell you one thing, this question, right, it came once in IIT exam, and the same question, right, also came in your NEET exam once. So it's a PYQ, this question. Surya, I started the poll, buddy. Priya gave the answer, Surya gave the answer in the chat box itself. Well done. Time is running out now. Quickly give your answers in the poll. Sanya B. See, when all of you answer in chat box, so easily we can guess that what's your answer, because the most probable answer is the final answer, right? I hope you know what is the meaning of most probable, right? The answer which is repeated most of the time. So most of you said B, and of course the answer is B here, right? Of course, 100% correct answer. So point is, x is the radius of the first Bohr orbit. So for first Bohr orbit, if I calculate the radius from the formula, it is 0.529 into n square, means 1 square, upon z. For hydrogen atom, z is 1 angstrom. So this they have given as x. So point is, what I can do, I can put 0.529 angstrom as x. I can put 0.529 angstrom, which is a constant, as x, right, in further calculation. Now, de Broglie wavelength we have to find. Now, formula for de Broglie wavelength is lambda equals to h upon mv, right? H is a constant. Now, I want mv. So, for any orbit, for any electron, right, whenever you want mv, always use angular momentum formula, because from angular momentum you can easily get the momentum value. So for angular momentum, MVR, right, of the third orbit. Please remember. So I'm writing R3 indicating that this is the angular momentum of the third orbit. So for third orbit, angular momentum will be NH by 2 pi, means 3 times of H by 2 pi. Correct? Now, momentum from here, MV, will be 3 times of H by 2 pi divided by radius of the third orbit. And radius of the third orbit we can easily find, right? Radius of third orbit will be 0.529 angstrom, which I can put x directly, right, into n square by z. So for third orbit, 3 square will be 9. And I hope it is hydrogen atom again. Yes, hydrogen. So 1. So for third orbit, radius will be 9x. So I can put 9x here. So it will be 3h upon 2 pi into 9x. You can cancel this out 3 times. So it will be h upon 3 into 2, 6 pi x. Now, can I put MV here to get my de Broglie's wavelength? Of course I can. H upon, instead of MV, I can put h upon 6 pi x. So denominator of denominator goes into numerator, 6 pi x. So h and h will be cancelled and your answer will be 6 into pi into x, and 6 into pi into x is nothing but b, right? So this time most of you have done it. I have trust issue like you. No, I don't have trust issues, but I always say to each and every person in this universe that never trust anybody for anything. Be self-dependent always, right? Do not even depend on your gadgets and all. Because if you do that, you will stay happy in your life for your whole life, throughout your life. Okay, so of course the answer is B here, 6 pi x. And point is, here, one thing I need to tell you, we do remember this formula very easily. I know that. We all remember this. Wavelength, de Broglie wavelength is h upon mv. But point is, we have more forms of this formula, right? This formula can be written in other ways also, right? From your physics also, you know that a momentum can be written as a square root of 2 into mass into kinetic energy. So that formula can be used here, right? And using that, I can write wavelength as h upon under root of 2 into mass of particle into kinetic energy. Not only that, here the formula can also be written in terms of stopping potential. I hope in your physics, if you have studied electrostatic chapter, so now you know very well about stopping potential. Many people, they have doubt when they are in class 11th regarding stopping potential. But I hope that you all have done electrostat, so you know it very well what is stopping potential. So here we have another formula in terms of stopping potential, right? Wavelength equals to Planck's constant upon under root of 2 into mass, and instead of kinetic energy we can write E, electronic charge, into V, where V is your stopping potential. So h upon mv, h upon under root of 2m kinetic energy, h upon under root of 2m E into stopping potential. From any of these you can expect question in the examination, right? And I already told you regarding the Bohr model that in Bohr model you have to remember the formulas of each and every parameter: energy, radius, angular momentum, and velocity. So now with this, let's move into the next question. It is again from dual nature, or you can say failure of Bohr model, Heisenberg uncertainty principle, right? We can never estimate, we can never calculate the exact momentum and exact position of an particle, of an moving particle, correct? Planck's constant is given. Question is, the uncertainty in momentum of electron, means delta P, is given to you 10 to the power minus 5 kg meter per second. Then what is the uncertainty in position, means delta x. So I hope you know we have a direct formula here, right, regarding delta x and delta P. So from that formula you can find, so please do that and answer it quickly, whether it is A, B, C or D. Please try to answer in the poll, at least along with the chat. Even if you are answering in the chat, still answer in the poll. Surya, Sanya, Ankita, Subodh, what's your target college? Which college you want to pursue your MBBS? Subodh gave the answer. KGMC, fantastic, or I should say fantastic. AIMS, okay, so I hope many of you have given the right answer this time. Correct. In the chat box also I can see it. So of course, correct answer for this question is C, right? And 100% right answer means all of you are right. And this is a direct, you can say, formula based question, right? If you know about Heisenberg uncertainty principle, then we have this formula that delta X into delta P means uncertainty in position and uncertainty in momentum, the error of both if you multiply. So it should be greater than or equals to h by 4 pi. But during calculation, what you do? You take it equals to h upon 4 pi. Now you have to just apply the values, right? Delta x we have to find. So delta x will be h upon 4 pi into delta p. H is 6.626 into 10 power minus 34 divided by 4. The value of pi, you know, it is roughly 3.14. And delta p in the question it is given. Why they write 1 into 10 power minus 5, I don't know. It should be always 10 to the power minus 5 only. So if you calculate, right, round off, forget about the magnitude like 6 upon 4 into 3, it will be nearly 0.5 something. This value 10 upon minus 34 upon 10 minus 5 will be 10 to the power minus 29, right? And this value round off if you calculate, because 4 into 3 is 12, 6 by 12 is 1 by 2, 1 by 2 is roughly 0.5. So not exactly, but roughly if I say it will be 0.5 into this, and if I do in scientific notation, so it will be 5 into 10 power minus 30, nearly, right? And the closest answer is C, and that was your answer in this case, which all of you gave it correctly. So C is the right answer, and I hope you will remember this formula of Heisenberg uncertainty principle. Now, can we do this one? Now we have a question from the quantum model, but it's an easier one, right? So please immediately give your answers, all of you, within 30 seconds. Which orbit would be the first to have G subshell? You know that in each orbit, in each shell, we have different number of subshell, right? Like first shell has only one subshell, S. Second shell has two subshells, S and P, 2s2p. Third shell has three subshells, SPD, 3s3p, 3d. So which orbit will be the one which will have the G subshell? So subshells are S, P, D, F, G, H, I, J, like that. Surya said C. Aquarius C60 said C. Subodh C. This time most of you are giving C, so definitely the answer should be C. And yes, it is. You know it very well, right? None of you answered in the poll. Why? My leaderboard is completely empty this time. Don't do that. Please answer in the poll. So point is, in your first orbit, you have only one subshell, that is S. In your second orbit, you have two subshells, S and P, and you name that as 2s2p. In your third shell, you have three subshells, S, P, D, and you name it in electronic configuration as 3s, 3p, 3d. So please understand 1s, 2s, 2p, 3s, 3p, 3d, 4s, 4p, 4d, 4f, they are nothing but your subshells, the name of your subshells. In the fourth orbit, fourth shell, you have S, P, D, F subshells, and in your fifth shell, you have S, P, D, F, and G subshell, and then in the sixth orbit, you have S, P, D, F, G, H, then I in the next, and then J, right? But we all know that currently the electronic configuration that we write, in them, we do not use GHIJ subshells. We do not keep electrons in those GHIJ. Currently, we are using only SPDF, right? So, of course, in the n equals to fifth orbit, right, first time we get our G subshell. And after this, in your n equals to 6, 7, 8 also, you will have the G subshell. So, they are asking that which orbit would be the first to have G subshell. G subshell will be there in 5th, 6th, 7th, 8th orbit. But first time it will be there in your 5th orbit. It is not present in 1st, 2nd, 3rd, 4th orbit. So definitely in this case, the answer is C. And most of you gave the answer in the chat box, right? Aquarius C60 also gave the answer C in the chat box. Please give the answer in the poll again. Now, the next question. Okay, so application of, you can say, electronic configuration. I hope you people are very good in writing down the electronic configuration, right? So question is, which of the following ion has the maximum number of unpaired d electrons? Unpaired d electron, not S, not P, not F, only D. So I will give a little bit of more time in this because you need to write down the electronic configuration for each of them, because then only you can check, because it's a comparison question. So let me give you 120 seconds. Now mark your answers, all of you. Surya, you are not getting any poll. It should be there. Srija, are you getting the poll? Subodh, are you getting the polls on your screen? Because this is auto-generated, it should appear on your screen. Shadow Gaming B, well done. Srija, you answered in some of the questions, right? Your name appeared in the leaderboard. My memorizing skill is little bit good. No poll. This time most of you gave the answer B, and let me tell you, it's a PYQ again. It's a previous year question of NEET exam, and the same question I have seen many times in JEE mains exams also, right? I hope you people know that JEE mains and NEET, they are not very much different with respect to chemistry. We get similar questions in JEE mains and NEET. Many of the questions I have seen which came in NEET, later on it came in JEE mains, and vice versa. So of course, for this question, the correct answer is B. And let me see the leaderboard this time. Shadow Gaming, Priya, Sanya, Mursaleen, Srija. Srija, you are answering. Surya and Aquarius. Okay. In this question, see why I kept this question, right? There is a purpose for it. Students, please remember that whatever question is there, that we have to find in which case we have maximum number of unpaired electrons in the d orbital. But point is, for that, we need to write down the electronic configuration. For cations, these all are cations, zinc 2 plus, Fe2 plus, Ni3 plus and Cu plus. Point is, please do not write electronic configuration of cations directly, right? Whenever you need the electronic configuration of cation, so first you need to write down electronic configuration of the parent atom. Because for cation, we can never write down the direct electronic configuration, correct? So for zinc 2 plus, if I want its electronic configuration, I need for zinc first, right? And for zinc, if you write down, zinc's atomic number is 30. So it will be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10. So its valence configuration is 4s2, 3d10. Now point is, when I go from zinc to zinc 2 plus, so I need to remove 2 electrons, and electrons are always removed from the last shell, not from the subshell having maximum energy, but electrons are always removed from the last shell, right? So here the last shell is 4th and it has 2 electrons in it. So these 2 electrons will be removed. So for zinc 2 plus, the configuration, the valence configuration will be 4s, 0 and 3d10. Now, why I'm not talking about the configuration of inner shell? Because before 4s, all the subshells are fully filled, so they do not contain any unpaired electron. So for unpaired electron, we need to check the valence configuration always. Now, in this case, because it is 3d10, you know it is fully filled. So if d10 is there, fully filled configuration is there, the number of unpaired electron in this will be 0, right? Similarly, for Fe2 plus, if you want the configuration, so first you should know the configuration of iron atom whose atomic number is 26, right? And for iron, the valence configuration will be 4s2, 3d6, and for Fe2 plus, I need to remove 2 electrons from the 4th shell, so it will become 4s0, 3d6. Now for 3d6, it is partially filled. So if I draw the orbital diagram, 1, 2, 3, 4, 5. So according to Hund's rule, according to Pauli exclusion principle, I need to fill the electrons here. So 6 electron means 1, 2, 3, 4, 5. First you give 1 electron each to each orbital and then you start pairing 6. So in this case, I can see clearly that we have total 4 unpaired electrons. Similarly, for nickel 3 plus, I need to know the configuration of pure nickel, neutral nickel. Atomic number of nickel is 28. Its configuration will be 4s2, 3d8. So for nickel plus 3, it will be 4s0, 3d7. And for d7, if I draw the orbital diagram, so d7 means 1, 2, 3, 4, 5, 6, 7. In this case, I have total 3 unpaired electron. And finally, for copper plus, right, first I need configuration of copper, which is, I hope you know that copper chromium have exceptional configurations, right? Copper is 4s1, 3d10 and chromium is 4s1, 3d5, and both copper chromium, they violate the Aufbau principle, right? In copper and chromium, right, electrons are not filled strictly according to the energy level. So for copper, configuration is 4s1, 3d10. So for copper plus, I need to remove electron from the 4th shell, so it will become 4s0, 3d10. Again, it is d10, so no need to check. D10 means it will have 0 unpaired electron. So out of these 4, right, highest number of unpaired electron we have in Fe2 plus, which is 4, then nickel 3 plus, which is 3, and then for D and A, zinc 2 plus and copper plus, the number of unpaired electrons are 0. And believe me, this type of question you get in your NEET exam, right? And this type of question, you can say that either it is from atomic structure, or same type of question we also get in the coordination compound chapter or in the D block chapter, F block chapter, right? Same concept, because electronic configuration is a backbone of your inorganic chemistry. So that's why same type of question you can find from atomic structure chapter, bonding chapter, D block chapter or coordination compound chapter. So this time almost all of you gave the right answer, right? But my point was, please never write down electronic configuration of cation directly. You can do that for anion. For anions, you can directly write the configuration. Like for O minus, right? For O minus, the total electron will be 9 and you distribute 9 electrons in 1s2s, 2p, 3s, 3p, right? You will get your configuration. But for cation, always write the configuration of parent atom first, then you go for the cation, right? So this question's answer was B. Now let's move for the next question. So first time now we have a statement based question, and if you read it, you will find that it is from quantum model. It is from quantum model, correct? Can you answer it quickly? Because you don't have to do any calculation. So let me start the timer of 30 seconds for you. Okay, I think it should be visible to you. Yeah, the options. Statement 1 is true, 2 is true, correct explanation. Statement 1 is true, 2 is true, not correct explanation. 1 is true, 2 is false, 1 is false, 2 is true. Surya 3D6. 3D6 I think you gave for the last question. Priya B. Okay. Mursaleen, I am pronouncing your name correctly. I hope so. B is the answer, Sania. Surya, you are from which city? Okay, so poll stopped already, and I was having some molecules of water. So in this case, definitely the answer is B, and all of you gave it right. So it's a good thing, like you know about nodes and all. We do get questions from the node part nowadays in the exam. So statement 1 here is, there are two spherical nodes in the 3s orbital. Now students, I hope you know that spherical node is also called as radial node. Both are same, right? So one is radial node, one is angular node. Radial node is also called as a spherical node because of its spherical shape, right? Now, counting of radial or spherical node can be done in two ways. Either you can apply the formula, right? For radial node, we have a formula which says that principal quantum number minus azimuthal quantum number minus 1, right? Like in this case, 3s orbital, the value of n is 3, for s, the value of L is 0, minus 1, so it will come out 2. So there are two spherical nodes in 3s orbital is absolutely correct statement. But point is, apart from formula, you can also find the radial node by looking at the shape of the orbital. I hope you all know that when you draw one sphere like this, so this is the 1s orbital. When you draw one more concentric sphere like this, right? So that's how your 2s orbital looks. And when you draw one more concentric sphere here, concentric hollow sphere, right? So total 3 regions, 1, 2, and 3. So this is the shape of the 3s orbital, spherical, right? And in between the regions where you can find electron. So these are the regions in 3s orbital where there is a probability of finding electron. This region can be the one where you can find electron. In this region also you can find your electron. In this region also you can find your electron. But between these 3 regions, we have certain gap, right? This gap. So this is one of the radial node where probability of finding electron is 0, where the value of psi square is 0. And this is another region where you don't get any kind of electron or where probability of finding electron is 0. So this is your second radial node, right? So if you know the shape of orbital, so from shape of orbital also you can find out how many spherical nodes you have, right? In the 1s orbital there is no spherical node or radial node. In 2s orbital there is one spherical node, right? In 3s orbital 2, in 4s orbital 3, and so on. In 2p orbital we don't have any radial node, but in 3p orbital we have one radial node, right? In 4p orbital we have two radial node, and so on. right? So first statement is absolutely correct. Now, second statement is there is a no angular node in the 3s orbital. This statement is absolutely correct. Again, angular node also you can find from the formula. Angular node is directly equals to the value of azimuthal quantum number L. And for 3s orbital, the value of L is 0. So here angular node will be 0. And all the s orbital, whether it is 1s, 2s, 3s, 4s, they are spherical in shape. So they are symmetrical around the 360 degree. So that's why in any of the s orbital, you don't have any kind of angular node. Angular nodes are there only in the p orbitals and d orbitals. In general, in your p orbitals, there is one angular node, right? And in your d orbitals, you have two angular nodes. But in your s orbitals, you don't have any kind of angular node. So here, both statements are correct, but the point is, these two have no relation with each other, right? So here what we need to answer, that statement 1 is true, 2 is true, but statement 2 is not correct explanation for statement 1, because what is the number of angular node in 3s orbital, right? That will not help you to calculate what is the number of a spherical node in the 3s orbital. So both are independent statements, both have no connection, right? So here answer is B, which you people already gave, most of you, but point is Sri Kakulam. Okay, I know Sri Kakulam. Like, I have been to Andhra Pradesh. Like, I have visited Vijayawada, Guntur many times for guest lectures in the year 2015-16, way back. Okay, so let's move ahead, and now we are done with the atomic structure, correct? So we saw questions from the mole concept, we saw questions from the atomic structure. Now we are into the third chapter, right? And this chapter, many students, they have fear of it, right? Please, if you see this according to me, so according to me, thermodynamics is the easiest chapter of chemistry. Why? Because thermodynamics is the one chapter which is directly related with your life, right? In your surrounding, right? In your 24 hours, whatever things you do, from those things only you can understand thermodynamics, and you can memorize the terms, the concepts of thermodynamics easily. So we have a question here, but it's a statement based question, so I can't give you much time in this. Start answering. Let me move it a little bit so that you can see the options. In thermodynamics, a process is called reversible when surrounding systems change into each other. There is no boundary between system and surrounding. The surrounding are always in equilibrium with the system. The system changes into the surrounding spontaneously. Aquarius, Priya, Sanya, Srija, Kenavan, Mursaleen. Many of you are saying that answer is C. So if you have the conceptual knowledge of thermodynamics, right, definitely you know that in thermodynamics, a reversible process is the one which stays always in equilibrium, right? And if your process is always in equilibrium, then at any time, right, you can move that process in forward or backward direction, right? So of course the answer will be C. The surroundings are always in equilibrium with the system. Now let's check how many of you are conceptually correct. All of you, very good. Sanya, Srija, Kenavan, Mursaleen, very nice. Immediately answered, very nice. So definitely in this case, answer is C. Now, see, what's the concept behind this question? Like when you start the chapter thermodynamics, so you have processes like gaseous expansion, compression, chemical reaction, physical change, temperature change, and those processes can be either reversible or irreversible, right? Irreversible means when you do the process only in one direction, like if you can only expand the gas, but you can't compress the gas at the same time, right? Then it is irreversible. But you can, if you can expand the gas and at the same time by applying force you can compress the gas, then it is reversible. So a process can be reversible only when it stays always in equilibrium state, right? And equilibrium is established between your surrounding and system, right? While if you have an irreversible process, so in the irreversible process, the equilibrium lies only at the end point, right? Now, can we go into the next question? Again, from the basic part of thermodynamics, right? In thermo, you talk about basic terms. What is system? What is surrounding? What is universe? What is extensive property? What is intensive property? What is state function? What is path function? Correct? So we have a question here now from the extensive and intensive property, right? Extensive is the one which depends on amount of substance, number of particle, and intensive is the one which does not depend on how much quantity, how much amount you have in a system, in a container, right? So out of boiling point, entropy, pH and EMF of cell, right? pH you have from ionic equilibrium and EMF you have from the electrochemistry chapter. So which one of them are intensive properties? Please answer it quickly, all of you. Sanya, no one should be angry anytime. Because Sanya, what I feel, anger is a kind of weakness, right? And you people are going to become good doctors, right? So you should to know very well about anger management, right? Many of you are giving the answer C. Sweta C, Mursaleen C, Sania C, Srija C. Very nice. Of course, the answer is C here. It's a very basic question. So let me end this. Of course, we got 100% right answers, and Mursaleen and Sweta immediately gave the answer. So point is, intensive property, right? Intensive means the one which does not depend on amount of substance. So if you talk about boiling point, right? So think like this. If I take 1 liter water, if I take 5 liter water, so whether it is 1 liter water, whether it is 5 liter water, the boiling point will remain same, 100 degrees Celsius, right? So boiling point does not depend on amount. That means boiling point is intensive, right? If you talk about pH, why I'm talking about pH? Because by the same example, I can explain pH, right? Subodh, are you there? If you take 1 liter water, if you take 5 liter water, right? In both the case, the pH will be 7 at 25 degrees C. So pH is the one for a solution which will not change just by amount of the solution. pH can change when you change the amount of your acid or base in the solution, right? But if you change the amount of whole solution, then the pH will not change, correct? And similarly, if you talk about EMF of a cell, right? So standard EMF or EMF, they are independent of amount, right? Like if you talk about SRP of copper 2 plus copper, right? So it is always 0.34 volt, correct? But of course, entropy, right? Entropy is the measure of degree of randomness, right? So point is very simple. In a container, when you increase number of particle, so with increase in number of particle, your entropy will increase. So entropy depends on quantity of matter, on number of particle. So entropy is extensive, but apart from entropy here, boiling point, pH and EMF, they are intensive, and that's why your answer was C. That means first, third, fourth, And fourth, EMF, pH, this is not third, this is third, pH and boiling point is intensive and entropy is extensive. Now, let's go ahead. Let's solve the next question now. So now you have a calculation. This is very famous question, very common question. If you will solve 10 questions of PYQ of NEET, out of 10, at least 4 questions will be from this work calculation. You know that PV work calculation is very important for us, right? In both the condition, in the reversible and irreversible. In reversible condition, it is minus 2.303 nRT log V2 by V1 or log P1 by P2. And in irreversible, it is simply minus external pressure into final volume minus initial volume, right? So according to question, you will have to judge, right, whether your process is irreversible or reversible. If it is mentioned that the process is happening under a constant pressure, so if it is written that it is under constant pressure, then it will be irreversible. And if you see that your volume pressure is fluctuating, right, then probably it will be reversible. So because we don't have to do calculation, we have to just write the expression. So let me start the poll. Please give your answer in the chat box, all of you. Arjun Reddy. I have seen that movie. Surya, you know, like in my initial days of teaching, like I started teaching in 2013. Initially 3-4 years, I visited almost each and every state of India just to interact with all the students. I had a curiosity that what's the difference between the students of Andhra, Maharashtra, Karnataka, Odisha, Delhi. But the point is, all of us have to study the same thing, same physics, same chemistry, same botany, same zoology. Okay, many of you giving the answer D. Yes, Sania, but I started teaching at a very early age. Like, I started teaching when I was 21. Just after passing from the college, I started teaching chemistry. I have a huge love for chemistry, you know. Chemistry is everywhere for me. No worries, Surya. This time you will crack, definitely. So, I can see that in chat box, many of you are giving wrong answers for this. I don't know why. Although it's a direct question. Can you see this, all of you? Question says that the work done in ergs, right, for the reversible expansion of 1 mole of an ideal gas from a volume of 10 liter to 20 liter at 25 degree. So point is, the general formula for reversible isothermal work, the general formula for reversible isothermal work is minus 2.303 nRT, or instead of nRT, according to question, you can write PV. If temperature is mentioned, use nRT. If pressure volume is given, use PV, right? So 2.303 nRT log base 10 V2 upon V1, right? Now here, right, minus 2.303, number of mole, right, is 1. They have mentioned in the question. Temperature is 25 degrees C, but temperature in any formula, we always keep in Kelvin, right? So 25 degrees C will become 298 Kelvin, right? So temperature I can put 298 Kelvin. right? And log V2 by V1. So final volume is 20 and initial volume is 10. So anyways, it will be 20 by 10. So here it should be log 2. And many of you answered D. D, we have log 0.5. It is not possible. Inside log, we should have 2, right? And this is present only in two options, these two, right? And then if you notice, right, in the first option, we have 298, which is the value of temperature, and the value of R, they have kept 0.082. No, if you keep R as 0.082, you will end up getting your work in terms of liter ATM unit. If you put R as 0.082, your work will be in liter ATM. If you put R as 8.314, then your answer will be in joules. If you put your R as 2, right, then your answer will be calorie. Here we want in ergs, right? So for erg, I can put R as 107 into 8.31, right? So answer will be B here, not D, right? Why many of you shadow gaming? That's the conversion factor between joule and erg, right? You people study means conversion of units in your physics units and dimension chapter. You should be good in converting the units of energy like joule, erg, calorie, right? And liter ATM. Liter ATM is also a unit of energy, right? 1 liter ATM is nearly 101.3 joules, 1 liter ATM. Correct? Henry, we started on time, exactly. Okay, so point is you should be able to calculate work in both reversible and irreversible process, right? Now, after calculation of work, now let's see the next question we have. Consider the reaction at 300 Kelvin, H2 plus Cl2 gives 2 HCl. For this reaction, the standard enthalpy change is given minus 185 kilojoule. 2 mole of H2 completely react with 2 mole of Cl2 to form HCl. Okay. If 2 mole of H2 will react to give 2 mole of Cl2, they will create 4 moles of HCl. What is the delta U? So again, we have a very standard question, very famous topic, right? Relation between enthalpy internal energy. Delta H equals to delta U plus delta NGRT. And from this topic also, we get questions in the NEET exam. So in this question, take your time, but please do it correctly, all of you. Don't do mistake in this. It's a very important question for you. Relation between delta H, delta U. Sometimes delta H is given, you find delta U. Sometimes delta U is given, you find delta H. And sometimes we get questions of comparison between delta H and delta U. That whether delta H, delta U are equal, whether delta H is greater than delta U, whether delta U is greater than delta H. This question you should do, all of you. I can see some of you are giving the answer. Shadow gaming, Sweta. Well done. You do not have much calculation in this question. Calculation is easier. The only major point here is calculation of delta NG. Many of you have already given the right answer, right? And many of you have already given the wrong answers, right? Please focus on the units. See, in thermodynamics, unit and sign conventions are very important. correct? You should know one thing, that standard enthalpy is always given per mole. Like if you talk about thermochemistry, so in thermochemistry, when you define different types of enthalpies, enthalpy of fusion, enthalpy of vaporization, enthalpy of sublimation, ionization enthalpy, electron gain enthalpy, any enthalpy, right? Under standard condition, you define that for 1 mole, right? Only for neutralization case, you define it for 1 equivalent. Shadow gaming, put your charger. This time, let's see how many of you have given the right answer, right? 0%. Most of you, I can say all of you, gave the answer B. Let me tell you why. See, one thing is clear, that in this question, if you calculate the delta Ng value, right? So delta Ng will come out 0. Delta Ng is what? Change in number of gaseous moles. So according to the reaction, in the product side, we have 2 moles of gas, right? So 2 minus, in the reactant side, 1 mole of hydrogen gas, 1 mole of Cl2. So in the reactant side also, total of we have 2 moles of gas. So delta Ng is 0. So clearly in this case, right, delta H will be equals to delta U, right? Delta H is equals to delta U plus delta NGRT. This is the complete formula we have. But because delta NGRT will be 0 here, so delta H will be equals to delta U, right? But point is, this delta H is the standard enthalpy change, and standard enthalpy change is always given for 1 mole. So for 1 mole, your enthalpy change is minus 185 kilojoules. For 1 mole, your enthalpy change is minus 185 kilojoule. Now enthalpy is extensive, right? Enthalpy will change when you change the amount. So for 1 mole, if it is minus 185 kilojoule, so suppose if I take 2 moles of Cl2 and 2 moles of hydrogen, right? So for 2 moles, right, it should be double. For 1 mole, if it is minus 185, so for 2 mole, it should be 2 into minus 185, which will come out eventually 5 into 10, 0, 18 into 2, 36 plus 137, minus 370 kilojoule, right? So please remember that all the standard enthalpy, they are defined per mole, right? And I think most of you did mistake here, correct? Because you forget that point. Am I right? Everyone? So answer should be D here. Yeah, minus 370. Clear? You know what? Sometimes from here I can recall a point. Sometimes from the enthalpy, you get direct question from the point that enthalpy is extensive property, right? I have seen questions from the previous year in which we get this type of question, that if carbon is getting converted to CO2, right? For this reaction, the enthalpy change is let's say 100, let's say minus 100 kilojoule, right? Then how much energy we will be getting by burning 100 grams of carbon? If I do the combustion of 100 gram of carbon, then how much energy I will be getting? So this is the question which is based on the fact that enthalpy is extensive, right? How you can do it? For this reaction, the enthalpy given, which is minus 100 kilojoule, it is per mole. Per mole means for 1 mole of carbon, for the combustion of 1 mole of carbon, I am getting this much amount of energy. Now, 1 mole carbon means what? 1 mole carbon means 12 gram of carbon. So I can apply unitary method here. 1 mole or 12 gram of carbon after combustion, it can produce 100 kilojoules of energy. So if I take 100 grams of carbon, so that will give you 100 upon 12 into 100 kilojoules of energy. So this type of question you can find in the NEET PYQ, but main thing is it is based on the point that extensive property is there. Enthalpy is extensive property. It depends on amount. It depends on amount. Correct? Now, let's do the next question. Can you do it? I think in thermodynamics, comparing the adiabatic process and isothermal process is important, right? Adiabatic is the one in which there is no heat transfer, Q is 0. Isothermal is the one in which temperature is constant, and for gases, delta U is 0 for isothermal. Delta H is also 0 for gases, right? But in adiabatic condition, one thing changes, right? For isothermal condition, for gases, you write that P into V is constant. But for adiabatic case, right, it is P into V power gamma is constant. And gamma is what? Gamma is your Poisson's ratio. And Poisson's ratio is defined as ratio of molar heat capacity under constant pressure and constant volume. Gamma is defined as Cp upon Cv, right? So in this question, they are asking that for monoatomic gas, the values of the ratio of Cp-Cv. So ratio of Cp-Cv is nothing but gamma, Poisson's ratio. And for monoatomic, diatomic, triatomic gases, you should remember these values, right, directly in your mind. So please immediately give your answers, all of you. I hope you all remember the value of gamma for monoatomic gas, and it's a direct question for us. Well done, Surya, Sanya, Srija, Shadow Gaming, Sweta, Kinavan. A is the answer. Of course, let me end this because it's a very much direct question. I just kept it so that you can recall the point that we have to remember the Poisson's ratio for monoatomic, diatomic, and polyatomic gases. Of course, all of you gave the right answer. Point is, when I take monoatomic gas like helium, neon, argon, and so on, so for them, gamma is 1 point, right, 66 or 5 by 3. When we take diatomic gases like O2, N2, NO, CO, right? So for diatomic gases, the value of Poisson's ratio gamma is 1.4, which can also be written as 7 by 5. And for triatomic or polyatomic gases, we consider gamma as 1.33, which also written as 4 by 3. So these relations of Cp-Cv, that Cp upon Cv is gamma, whose value depends on atomicity. And one more relation we have between the molar heat capacities, it is Cp minus Cv equals to R, right? These two relations you should remember for the adiabatic process. One more point, I need to write it down here. For adiabatic condition, you should know that PV power gamma remains what? Constant, right? Sometimes you do get question from this. In adiabatic process, in adiabatic expansion or compression, initial pressure volume is given, final pressure volume you will have to calculate. So in those types of question, you need to apply P1 into V1 power gamma equals to P2 into V2 power gamma, right? So with this, now, of course, in this question, the answer was A, that is 5 by 3 because it is monoatomic gas. Now let's see the next question. Can you do it? Can you solve it? This time we have a question of entropy. And if I give you a quick revision of thermodynamics, you should know that in the thermodynamics chapter, we only do calculation of parameters. We do calculation of Gibbs energy change, entropy change, enthalpy change, internal energy change, Cp, Cv, right? And finally work, reversible and irreversible. That's your syllabus for thermodynamics. So let me give you a little bit of more time in this. I have started the poll. Solve your question using the pen paper and then give your answer. Surya wrote the values of gamma in chat box. Well done. Now solve the question from calculation of entropy change. So let me check how many of you have done it correctly. Aksh, Sanya. So stop it now. Wow. Aksh, Kanavan, Sanya. Well done, all of you. So if you read the question now, calculate the total entropy change they are asking. So here we have a difference in question. Normally in thermodynamics, you get questions of calculation of entropy change for system mainly, right? Sometimes you get questions of calculation of entropy change for surrounding also. But this time in this question, we have to calculate, right, the total entropy change, means change in entropy of system plus change in entropy of surrounding. And I hope you know that it is related with the second law of thermodynamics, right? Second law of thermodynamics says that when the total entropy change of system surrounding is positive, so then your process is spontaneous. And when the total entropy change of system surrounding is negative, then your process is non-spontaneous. And if entropy change total system plus surrounding is 0, that means your process is at equilibrium. So in this case, we have to calculate the total entropy change. Now, the process here is transition of 1 mole sulfur from the monoclinic to rhombic. So it's a allotropic transition, monoclinic to rhombic. Delta H is given. So this is the amount of energy, amount of heat that is getting transferred between your system surrounding. For the transition, assume surrounding to be in ice water, right, at 0 degree. So your surrounding is at 0 degree. 0 degree means how much? 273 Kelvin. More precisely 273.15, but we take 273 Kelvin. And the conversion is happening at 368 Kelvin. Now point is, when you try to calculate entropy change, the most fundamental formula of entropy change is Q by T, right? And for physical change or chemical change, right, the amount of heat transfer can also be written as delta H by T, right? General formula is Q by T, right? And now depending upon process, you can change Q, right? Like for reversible isothermal process, Q becomes equals to, right, work, correct? And for physical and change and chemical change, Q can be written as delta H. So delta H by T we can apply here to calculate the entropy change. But point is, we have a difference in the temperature, right? Surrounding is at 273 Kelvin and the process or system is at 368 Kelvin. So if I calculate entropy change of system, so it should be amount of enthalpy change, which is 401.7, right, divided by, for system the temperature is 368 Kelvin, and if I calculate that for surrounding, so energy transferred between system surrounding, so same magnitude will be there, 401.7 upon temperature is different, 273. Now the main thing is sign convention, right? If delta H of your reaction is negative, that means it's an exothermic process, means your surrounding is gaining the heat and your system is losing the heat. So for system, you can apply negative sign. For surrounding, you can apply what? Positive sign, right? And now if you calculate both and if you add both, you will get your final answer, correct? So this plus this, if you do, it will come out nearly 0.38, right? Sania, are we getting 0.38 here by adding these two? 401.7 upon 273 minus 401.7 upon 368. We should get. And answer is 0.38 only. Yeah, 0.38. But point is, in this question, what is happening? Your heat energy is going from system to surrounding, right? So system is losing heat, surrounding is gaining heat. So for system, I am taking heat as negative minus 401.7, and for surrounding I am taking it positive, plus 401.7. And your system surrounding is at different temperature, right? So for system, the temperature is 368 Kelvin, and for surrounding, we are taking 273 Kelvin. Then calculate entropy for both, entropy change for both, and you add it, you will get your answer as 0.38 joules per Kelvin. Correct? Now, let's move ahead. Let's see few more questions. For the reaction at 300 Kelvin, reaction is A plus B gives C, right? It's a random reaction, but it is balanced. Assume that. Delta E in chemistry, you can say it is also equals to delta U, right? So delta E or delta U here is minus 3 kilocalorie. Delta S or entropy change of the process is given, and you have to find not G, you can't find G, you have to find delta G, change in Gibbs energy, right? You will require certain time here in this. So start calculating. I have started the poll. For the previous question, we are getting 0.379. So in round off, you can say 0.38. Correct. It's a question of relation between delta H and delta U, and relation between delta G with delta H and delta S. But whenever you solve this type of problem, please focus on the units, because somewhere it is joule, somewhere it is kilojoule. So you need to take in the same unit. Somewhere it is calorie, somewhere it is kilocalorie. So follow the principle of homogeneity. Let me end this poll, and for this question, the correct answer is A, and wow, nice. It's a PYQ, so not PYQ, the values are changed. Similar question we got in the NEET exam also, but the values were different, and you people solved it. Very nice. So point is, here this is a reaction, which is our process, right? And for this we have to calculate delta G. So what we can do? Delta G is calculated by delta H minus T delta S, right? So we don't have delta H, but we have delta U. But we know that for a reaction, especially for a chemical and physical reaction, delta H can be calculated as delta U plus delta NGRT. We did previous question from the same formula. Now delta U here, it is minus 3 kilocalorie. Minus 3, please remember the unit kilocalorie. If I convert into calorie, it will be 1000, right? So 3000 calorie now. Plus delta Ng here, it will be number of moles of gaseous product, which is 1, minus reactant, which is 2. So in the product side, we have 1 mole of gas. In the reactant side, we have 2 moles of gas. So 1 minus 2, it will be minus 1. R, I can take 2 calorie, and the temperature is 300, right? So it will be minus 3000 plus minus minus, and 2 into 3 is 600. So it will come out minus 3600 calorie. So that's the value of your delta H. Now substitute the value. Delta H here we have minus 3600 minus temperature we have, which is how much? 300. And entropy we have, delta S we have, which is minus 10. Minus 10. So if you calculate, it will be minus 3600 minus minus plus 300 into 10 is 3000, right? And minus 3600 plus 3000, you know that it will come out minus 600. But the point is, we need two formulas to solve this question. One, delta G equals delta H minus T delta S, and from that also you get direct question sometimes. And other one, delta H equals delta U plus delta NGRT, right? So sometimes you get question from this, sometimes from this, and sometimes connecting these two formulas, you get the question in the exam. So here, of course, the answer was A, minus 600 calorie. Now let's quickly move on to the next question. Can you solve it, all of you, quickly? And I think now from thermodynamics, right, we got a transition, and now we have a question from chemical equilibrium, right? So from thermodynamics, in NEET, you will be getting questions of calculation of delta G, delta H, work, parameters in adiabatic condition, and sometimes a basic problems from extensive, intensive, state function, path function. Please solve this question quickly because it's not a tougher one. So I'm starting the poll. It's a very fundamental question of chemical equilibrium, very fundamental. And if poll is visible to you, please answer in the poll option A, B, C, D. Which one is the right answer? Okay, so let's check it out. What's the right answer here? Some of you gave A, some of you gave B. But the right answer is A. Oh, many of you got B here. Let's see. We have the reaction, which is very simple. A, B converts to, of course, it's a reversible reaction. So we need to write down like this. So A plus B gives C plus D. All are gases and coefficient for all is 1. Stoichiometric coefficient for A, B, C, D, all is 1. Now this is studied in a 1 liter vessel at 250 degrees Celsius. The initial concentration of A was 3N. So initially, when we started the reaction, A is 3N, right? And that of B was N. So these are the initial amount of A and B. And if it is not mentioned in the question, so by default, we take product as 0. If it is given that initially you have certain amount of product, so take that amount. But if initially they have not given the amount of product, so by default, we take product as 0, right? Now, the reaction will start, and after certain time, it will reach equilibrium. Now, point is, assume in these types of question, do not read the question further. First, you assume that, let's say that till equilibrium, X moles of A is reacting. Till equilibrium, X moles of A is reacting. So at equilibrium, A will remain how much? 3N minus X. And with one part of A, one part of B will react. So X part of A will react with X part of B. So B is initially N and X mole of B will also react. So finally B will be how much? N minus X. And here also coefficients are 1. So one part of A will produce one part of C, one part of D. So X mole of A, if it will react, so it will produce X mole of C and X mole of D, right? I assume that till equilibrium, X moles of A is reacting. And using that, I calculated amount of each term at equilibrium. Now read the question further. When equilibrium was attained, right, the equilibrium concentration of C was found to equal to the equilibrium concentration of B. So at equilibrium, C and B have same concentration. C and B have same concentration, right? So same concentration means they will have same moles also, because overall for both the volume is 1, right? So if I equate that according to question, concentration or moles of C equals to concentration or moles of B. So X will be equals to N minus X, right? Because C is X mole and B is how much? N minus X mole. So from here you can easily say that 2X will be N. So X will be how much? N by 2. So N by 2 moles of A is reacting. Now what they are asking, what is the concentration of D at equilibrium? D at equilibrium. So concentration of D at equilibrium is X, but we got X as how much? N by 2. So answer will be N by 2A, but many of you answered B. I guess you people answered amount of A instead of D, right? Sir, in question 8, can we directly use the 12400 upon wavelength in, so we get energy in EV and then we can find. Of course, you can use, if you can remember that formula, Priya. Well done. You can use that. So for this question, answer is definitely A, right? And always read the question carefully. Many students, they do that mistake even in the examination, right? And later on, they will tell you that oh, I have done silly mistake. Believe me, that's not silly mistake, right? It's a blunder. You just ruined your examination by that. So before solving the question, before going into the concept, the first task for us is always read the question carefully, right? You must have noticed one thing. Whenever I solve a question, right, I underline the question. Why? Because I do not want to mess with any values, right? I try to be always careful while reading the question, and you should also do that. Be careful when you read the question. So let's jump into the next question of chemical equilibrium again. Let me start the poll. This time 45 seconds for you. Can you answer it, all of you? When alcohol and acetic acid mixed, you know that it's called esterification reaction. Together in equimolar ratio, means equal moles initially. 33% of each converted into ester, then Kc for the equilibrium. So it's a question of, okay, when you talk about chemical equilibrium, it's a very small chapter, right? Very small chapter. We have only 2-3 topics in it. First topic, how to find concentration or moles of each term at equilibrium, or pressure of each term at equilibrium. Then how to find Kc, how to find Kp, and what is the relation between Kp, Kc, right? Kp equals to Kc into RT power delta Ng. And finally, we have a conceptual part, which is Le-Chatelier principle, right? How concentration, temperature, pressure, catalyst, addition of inert gas affects the equilibrium state. Correct? So for this question, let's see how many of you gave the right answer. Answer is B here. Oh, none of you solved it. It was an easy question, right? I can write the equation in a generalized form, right? We know that alcohol reacts with acid. It's a reversible reaction to produce ester along with water, right? Now question is, initially both are equal. So initially, right, if this is n mole, so this is also n mole, and by default product is 0, correct? Now, after certain time, when equilibrium is established, they have given information for us that 33% of each converted into ester. So 33% reaction is happening. So this is basically, you have the degree of dissociation, right? This is percentage dissociation 33, right? Degree of dissociation will be 0.33. So out of n, 0.33 part will react. So how much you are left with if 0.33 n part will react, right? So roughly you are left with 0.67 n part, and here also 0.67 n part. And how much ester you will be getting? Same 0.67 n part. No, not 0.67 n. 0.33 n part is reacting, so you will be getting 0.33 n. And skip water because water is in pure liquid state. So I hope you know that very well, that when you calculate Kc, so if a substance, if a reactant product is in pure solid or liquid state, so you need to ignore that, or you put concentration of that term as unity, right? So now if you calculate the Kc value, correct? So Kc here, it should be 0.33 n, right? Here n is not mole, here n is concentration. Please be careful in that, right? And power 1 into 0.67 n power 1 into 0.67 n, right? Power 1, correct? And if you do the calculation, you will get your answer. Okay, here each term is liquid. Okay, so we have a contradiction here. because if each term is liquid, then for each term we can put the concentration 1, right? So by that Kc will be 1. So I think in this question, what they are trying to say, according to the question, they are trying to say that each term is in aqueous form, right? Of course, then it will be a hypothetical case. So we assume that everything is aqueous here, right? If everything is aqueous here, then I will have to consider water also, 0.33 N, right? But that's a completely hypothetical case. Please remember that for pure solid liquid, you take concentration unity, right, Sania? I hope you know that, right? For pure solid liquid, we take concentration as unity while calculating Kc, right? But here it's a kind of hypothetical case we have. And if you do the calculation, N will be cancelled and this will be cancelled 2 times, this will be cancelled 2 times, right? So your final answer will become 1/4. So B is your answer, correct? But see, the main point is you should understand how to calculate Kc. Get the concentrations of each term at equilibrium, right? Then concentration of product upon reactant raised to the power stoichiometric coefficient. Now, let's move ahead. Let us see the next question. And it is from KP now. After KC, now we have a question from KP. Please do it, all of you. Sania, Aquarius C60, Priya, Subodh. I hope you people can see the poll. Can one give the answer B? Well done. Because that is the answer here. Answer is B, right? And only one person gave the right answer. Anyways, see, it's a question of Kp. Now, when you deal with Kp, so you need to do the calculation not in terms of concentration or pressure. Sorry, not in terms of concentration or mole, but in terms of pressure, correct? Like in this question, we have carbon, which is solid. Then we have CO2, which is a gas, right? And then we have twice of carbon monoxide, which is a gas again. And in the reaction, 12 atm is your equilibrium pressure, means when equilibrium has been established, so then your pressure is 12 atm. And one more thing is given, 50% of CO2 reacts till equilibrium, right? So point is, in this case, I will assume initially not the number of moles, not the concentration, but pressure. I will assume that initially the pressure of CO2 is P. Of course, carbon is solid, so ignore that, because solid, liquid or aqueous, its pressure we take unity in calculation of Kp. So initially the pressure of CO2 is P, so this will be 0, right? Now, till equilibrium, 50% of CO2 is reacting. So out of P, half of pressure will decrease, right? Half of pressure will decrease because CO2 is reacting. So 50% of P is how much? P by 2. So P by 2 part of CO2 will react in terms of pressure. So at equilibrium, it will be P minus P by 2. That means P by 2. Clear? Now, with one part of CO2 reacting, two part of CO will be formed. So if pressure of CO2 is decreasing by P by 2 amount, so double, that means P by 2 into 2, the pressure of CO at equilibrium will be P, right? So at equilibrium, forget about carbon because it is solid. The pressure of CO2 is P by 2 and the pressure of carbon monoxide is P. Now the total pressure, that means P by 2 plus P is given for us, which is 12 atm. So from here, you can find the value of P. It will be P plus 2P, means 3P equals to 12 into 2, 24. So P will be 8. Now if P is 8, So the pressure of CO2 at equilibrium will be 8 by 2 means 4, and the pressure of CO will be simply 8. Now from this, because you have the values of pressure at equilibrium, you can find Kp. So Kp is what? Kp here is pressure of CO power 2 upon pressure of CO2 power 1. Leave the carbon part because it is solid. So pressure of CO is 8. So 8 power 2 upon pressure of CO2, which is 4, power stoichiometric coefficient 1. If you calculate 8 8 is 64 upon 4 will come out 16. So your answer will be how much? 16 atm. So point is, whether you calculate Kc or Kp, right? In both the cases, you follow the same technique, right? Equation, balanced equation, right? Initial amount, concentration or pressure, right? And after certain time at equilibrium, what is the value of equilibrium, mole or pressure, that you have to calculate. And from that, accordingly, you can find Kc as well as Kp. Now, can you do the next question, all of you? This time you don't have to do the calculation, much calculation, right? It's a question of, I guess, relation. No relation. In which of the following reaction increase in the pressure at constant temperature does not affect the moles at equilibrium? So it's a question of Lee-Chatelier principle, right? Effect of pressure at equilibrium, correct? So because it's a conceptual question, you don't require much time. So please immediately give your answers, whether it is A, B, C or D. Kenavan, let's do now as many questions we can do today. Today we are trying to cover the whole physical chemistry, and if you have the idea of your syllabus, you should know one thing, that physical chemistry is almost 50% counting wise. If you count the number of chapters, if the total number of chapters are 22, then out of 22 chapters, almost 10 or 11 chapters are from physical chemistry now, including both 11th and 12th. Well done, right? So of course, in this case, many of you gave the answer, Srija, Kenovan, Ravita, Sanya. The answer is absolutely correct. It is D. None of you gave the answer in the poll. No worries. See, point is, the effect of pressure, right, is not there on equilibrium when for a reaction delta Ng is 0. Delta Ng, just now we have seen in the thermodynamics question, right? Delta Ng is number of gaseous moles in product side minus number of gaseous moles in the reactant side. So for a reaction, if you calculate delta Ng and the value of delta Ng is 0, right? So if delta Ng is 0, that means you will have no effect of pressure at equilibrium. Now, out of all these options, if you notice, in the first case, reactant side we have 4 moles of gas. In the reactant side, we have 2 moles of gas. So for the first case, delta Ng will be 4 minus 2, which is 2. In the second case, we have 1 mole of gas in the product, and we have 1.5, means 1.5. So 1 minus 1.5 will be again minus 0.5. In the third case, 1 mole here, and 1 and 1.5 mole here. So 1 minus 1.5, this will be minus 0.5. And in the last case, 2 moles of gas in the product and 2 moles of gas in the reactant. So in the last case, delta Ng will be 0, and if delta Ng is 0, that means there will be no effect of pressure. So in this case, of course, your answer will be D, but you should also know one thing, that when you increase pressure, if delta Ng is not 0, like suppose if I consider the first condition, right, in which the product side, the gaseous moles are 4, and on the reactant side, the gaseous moles are 2. So in these cases, when your delta Ng is not 0, right, if you increase pressure, reaction goes towards that side where you have less number of moles. Like in this first case, if I increase pressure, reaction will go backward. And if you decrease pressure, then your reaction will go on that side where you have more number of gaseous moles. In this first case, if I decrease pressure, my reaction will go into the forward direction. But if delta Ng is 0, there will be no effect of pressure on the equilibrium state, right? So now let's do the next question. Can you do it? Another question, right? But this time we have a question from, you can say, reaction quotient. Remember QC, QP? for any reaction at any instant, if you calculate QC or QP, so by comparing Q with equilibrium constant, you can tell that from that state whether your reaction is going in forward direction or backward direction, right? So let me start the poll for you. Can you immediately give your answers, all of you, quickly? A reaction mixture containing H2N2NH3 has partial pressure 2 atm, 1 atm, 3 atm, respectively. If the value of Kp for the reaction is given 4.28, okay, here you have 4.28 into 10 power minus 5, right? atm inverse square. In which direction the net reaction will go? Let's see how many of you have given the right answer. Okay, some options I can see B, some D. No, the right answer is of course B here. Okay, again, none of you gave the right answer. See, it's a very simple question. Our balanced reaction is N2 plus 3H2 gives twice of NH3. Now, we have an instance in this reaction at which the pressure of H2 is 2 atm, 2 atm. The pressure of N2 is 1 atm, 1 atm. And at the same instance, the pressure of NH3 is 3 atm, right? 3 atm. So point is, at this instance, I can calculate the Q value, reaction quotient, right? QP. QP will be calculated same like your equilibrium constant, but equilibrium constant is calculated only at equilibrium state, and QP, QC can be calculated at any random state. QP, QC you can find at any state, right? So at this state, if I find QP, it will be pressure of NH3 power 2, so 3 power 2, divided by pressure of N2, which is 1, into pressure of H2, which is 2, power coefficient 3. So this will be 3 3s are 9 upon 2 power 3 will be 8. So this will be nearly 1 point, right? 8 1s are 8, 1 something, right? Now point is, at this state, I calculated QP, I got nearly 1.1. Now for the same reaction, the value of Kp is given. Kp is how much? 4.28 into 10 power minus 5. If you notice carefully, students, Kp is much smaller as compared to Qp at this state. So I can say that at this particular state, Qp is greater than Kp, right? If Qp is greater than Kp, right? So from that state, the reaction will go in backward direction, right? If Qp is less than Kp, so from that state, your reaction will go in forward direction. And if you get Qp equals to Kp, that means your reaction is already at equilibrium state, right? So in this case, your answer should be B, that means backward direction, correct? So it's a question of extent of reaction, and believe me, all these topics are there. Sir, again, I do it correct. Answer, why not leaderboard mention the name? Maybe there can be some network issue from any side, right? Don't worry about it, because here we are here to learn to discuss the concepts of chemistry, right? Let's do the next one now. For the reaction, twice of NO2 gives twice of NO plus O2. Kc is given at this temperature. R is given. Okay, so here we have to now compare the values of Kp, Kc, that whether Kp is greater than Kc or whether Kc is greater than Kp, correct? So please do it. We have only one relation between Kp, Kc, right? Kp is equals to Kc into R into T power delta Ng. K1 V9Z A. Answer in the poll also. Of course, it is A, right? Only one answer. Maybe some of you have network issues. Of course, answer is A here, right? No doubt in that. Kp is greater than Kc, and why this is? Because we have only one relation here, Kp equals to Kc into RT power delta Ng, correct? Now point is, you don't require these values here. You don't require these values of Kc. You don't have to do the calculation. You have to just compare on the basis of value of RT delta Ng, right? So Kp equals to Kc. R is how much? 0.083. 0.083. And temperature is how much? 184 degrees C, but I need in Kelvin. So add 273 to it. It will be 3 plus 4, 7, 8 plus 7, 15, 1, 2 plus 1, 3 plus 1, 4, 457, right? And delta Ng will be gaseous moles of product, so 1 plus 2, 3 moles in the product side and 2 moles in the reactant side. So 3 minus 2 will be 1. So delta Ng is 1. Now students, if you look carefully, so 457 into 0.083 will be definitely greater than 1. No need to calculate here. You can directly see that this value will be 100% greater than 1. So Kp will be Kc into a number which is greater than 1. That means Kp is 100% greater than Kc. Right? So no need to do the further calculation. Directly we can say here that Kp is greater than Kc. And suppose if this value is less than 1, right? In that case, I can say that Kc is larger, but Kp will be smaller. So for this question, the answer was A. Now let's move and let's see the next question. So in chemical equilibrium, because now we are starting with the questions of ionic equilibrium here. In chemical equilibrium, I hope you have understood that we get either questions of Kp-Kc calculation or relation between Kp-Kc, or questions from Lee-Chatelier principle, right? In Lee-Chatelier principle, effect of concentration, temperature, pressure, inert gas addition, all are there, right? Correct? So later on, if you want, you can do the practice, right? All of you must have lots of questions with you. So those questions also you can practice if you feel that any particular topic is weak for you, right? Now, can you do this one? It's a direct question, so I will not give you much time in this. I will start the poll immediately. Identify the amphoteric species. So in ionic equilibrium, we start with concept of acid base, right? Concept of Arrhenius acid base, Bronsted acid base, Lewis acid base, right? And in that also, Bronsted concept is important. Bronsted concept is important. So I got some answers D, some answers B in the chat box, right? But believe me here, all of them are amphoteric. All of them are amphoteric. The correct answer is D here. Only 20%? Why? Paramparik. Okay. Why so many wrong answers? Why you answered B, many of you? Identify the amphoteric species. See, according to Bronsted, amphoteric species is that one which can accept and donate H+, which can both donate and accept H+, right? And H2O, NH3 are the famous examples that is even given in your NCERT, right? Water and NH3, they are amphoteric according to Bronsted, because water can accept H+ to create hydronium ion, and water can donate H+ to create hydroxide ion. So water is amphoteric. NH3 can accept H+ to give ammonium ion. NH3 can donate H+ to give NH2 minus ion. And NH3, right? We have some reactions, important reactions in the organic chemistry, right? Do you remember Birch reduction, all of you? In Birch reduction, when you convert alkynes to transalkene, so there you use NH3 with lithium or sodium, right? And in that reaction, NH3 acts as a proton donor. NH3 gives you H+. So NH3 can give H+ in reactions, and it can accept H+ also. And H2PO4 minus, it can gain H+ to create H3PO4, and it can lose H+ to give HPO4 2 minus. HCO3 minus can lose H+ to give CO3 2 minus, and again it can gain H+ to give you H2CO3. So all of them, they are amphoteric in nature. So that's why in this case, for this question, the answer will be D. And believe me, this type of question from Bronsted acid base, you will be getting in your exams also, right? Sometimes they simply ask which is Bronsted acid, which is Bronsted base. Sometimes they ask which is amphoteric. Correct? Now, the next question we have from Ionic Equilibrium. Okay, if I talk about Ionic Equilibrium, you should know one thing, that in Ionic Equilibrium, you get questions either from concept of acid base, or question from pH calculation, or from the solubility product. The major part is pH calculation, right? pH of strong acid, strong base, weak base, right? Salt, mixture of acid base, buffer, right? And then solubility product, ionic product. So here we have a question. The dissociation constant of acetic acid at given temperature is 1.69 into 10 power minus 5. The degree of dissociation of 0.01 molar acetic acid in the presence of 0.01 molar HCl. It's a question of common ion effect. It's a question of common ion effect, right? Paramparic sodium and liquid chemistry is used in Birch reduction. And even that reaction is important for NEET because we get trans alkene in them. So let's start the poll here. I can give a little bit of more time in this. Let's give 60 seconds because you need to do a little bit of calculation in it. I hope you people are not tired, right? Welcome back, Surya, after long time. Ravita, C. Sanya, C. Of course, the answer is C because I think you can guess one thing in this question. The rest of the options A, B and D, they are not at all close to the actual dissociation constant value. So even without solving, you can guess from the option that the answer will be C here, right? And yes, it is. And Surya, Ravita, Sanya gave the correct answers. See, point is, it's a question of common ion effect. In common ion effect, I want you to know one thing, that whenever there is a common ion in a solution, right? So you need to take the total concentration of common ion in any calculation, right? So this dissociation constant, right? It depends on temperature, you know that. K always changes when you change the temperature. If you don't change the temperature, the Ka, Kb, Kw remains constant. So point is, acetic acid dissociates into acetate ion and H plus ion. Now, the dissociation constant of acetic acid at a given temperature is this, the degree of dissociation of 0.01 molar acetic acid. So if I take 0.01 molar acetic acid initially, so initially these ions will be 0, and degree of dissociation if I assume alpha, so you know what is degree of dissociation, right? Degree of dissociation tells you that how much amount will dissociate, right? Initial amount into degree of dissociation is your dissociated amount, right? So 0.01, and if degree of dissociation is alpha, so 0.01 into alpha will be the dissociated part, right? So here, dissociated part is 0.01 alpha. So after dissociation, acetic acid will be 0.01 minus 0.01 alpha, and these two will be one part of this can create one part of acetate ion, one part of H plus ion. So 0.01 alpha part of acetic acid will produce 0.01 alpha part of this and 0.01 alpha part of this. But point is, here acetic acid is not pure. It is mixed with 0.01 molar HCl. So HCl, which is a strong acid, it will decompose into H plus and Cl minus in the same solution where you have acetic acid, right? Now HCl, if it is 0.01 molar, so it is a strong acid, it will dissociate completely. After dissociation, it will become 0 and it will give you 0.01 molar of H plus and 0.01 molar of Cl minus. Now, if you want to calculate alpha, you need to apply the formula of dissociation constant of acetic acid, right? So Ka will be equals to concentration of acetate ion, which is 0.01 alpha power 1 into concentration of H plus ion. Now here you have to focus. H plus we are getting from acetic acid. Also, we are getting H plus from the HCl. So when I put concentration of H plus, I need to take the total concentration because H plus is a common ion here. Right? So while calculating K in the solution of HCl, the total concentration of HCl I will take 0.01 alpha plus 0.01. Right? This we are getting from HCl and this we are getting from acetic acid. Correct? Now divided by the concentration of acetic acid, which is nothing but 0.01 minus 0.01 alpha. It can be written as 0.01 into 1 minus alpha. Now you can easily calculate this because common ion effect has a benefit, right? Ka, you can put 1.69 into 10 power minus 5. And in this expression, as compared to 0.01, this term will be ignored because 0.01 alpha will be very, very small as compared to 0.01. Also, out of 1 minus alpha, alpha will be ignored. You can see that K is very small, 10 power minus 5. So alpha will be less than 1. Alpha will be 0.01 alpha will be very much less than 0.01. So if you ignore these two, your calculation will become very easy now. Even this 0.01 will be cancelled by this 0.01, right? So alpha will be simply Ka, right, divided by Ka divided by 0.01, which will come out 1.69 into 10 power minus 3. So point is alpha or K can be calculated from each other. Alpha is calculated from K calculated from alpha. But whenever you have common ion, whenever you have more than one electrolyte in your solution, so in any calculation, always take the total concentration of common ion. And common ion helps you with the calculation. Due to common ion here, you can notice that you can very easily find the alpha value, right? So common ion will always help you in the solubility calculation also from KSP and in the alpha calculation also from the K values, right? So in this question, definitely the answer is C. That means 1.69 into 10 power minus 3. Now let's move ahead. Can you do this question? Okay, in the pH calculation, right? When you have a simple strong acid, strong base, right? So there you directly apply minus log H plus minus log hydronium ion, POH as minus log OH minus. But you have to memorize certain formulas, especially for the salt pH and for the buffer pH. So for the pH calculation of salt and pH calculation of buffer, you need to remember the formulas, right? Because with that you can easily solve the definitely you can, Ganesh. Definitely you can. Okay, let me start the poll. I forgot it. So I will give you less time now. It's a direct question, I think, from the calculation of pH of buffer. You can clear that slowly by sufficient preparation, Ganesh. Don't worry. So most of you gave C answer. Some of answers I can see B here. Definitely in this case, answer is C. Well done. So Nivas, Surya, Kenavan, Sanya, Paramparik. Well done. See, pK of weak acid, pKb of weak base given, pH of aqueous solution of the corresponding salt. So you know very well that when you have a salt of weak acid, weak base, so for that pH can be calculated as half into 14 plus pKa minus pKb directly. When it is a salt of weak acid, strong base, so there you have a 14 plus pKa plus log C. C is concentration of salt. When it is a salt of strong acid, weak base, so in that case pH is half 14 minus pKb minus log C. But here we have salt of weak acid, weak base. So for that pH has this formula. Now just apply the values, put the values half 14 pK is given for you. pK is how much? 4.80. So pK I can put 4.8 minus pKb is given 4.78, right? And if you do the calculation, it's very simple. Half, right? 4.8 minus 4.78 is 4.02. So it will be 14.02, and half of 14.02 is nothing but 7.01. So definitely in this case, in this question, the answer will be C, and many of you gave the answer. Yes, Paramparik, Nivas, Surya, well done. Ganesh, if you pass all the exams, definitely you can. Nothing is impossible, buddy. Always believe in yourself, right? Look around you. You will find many examples where people have started from the ground and they have reached the sky. So don't worry, believe in yourself and proceed. So let's proceed here. To prepare a buffer of pH 8.26, again we have a question of buffer only, but it's a salt of a weak base strong acid to be added to 500 ml of 0.01 molar ammonium hydroxide weak base. So I hope you know that when you add a weak base with its conjugate acid, when you add a weak base with its conjugate acid, so you create a basic buffer, right? And for acidic buffer, formula is pH equals to pK plus log concentration of salt by acid. And for basic buffer, the formula is POH equals to pKb plus log concentration of conjugate acid or salt by concentration of base. So use that formula, calculate it, and give your answer quickly, all of you. Because we don't have much calculations in them, that's why I am not giving much time here. So most of you are giving B, right? Of course, B is the right answer. Oh, some of you clicked on A. Let's see the leaderboard. Kanavan, Surya, Paramparik, well done. Of course, in this case, answer is B, right? Why it is B? Because it's a direct question. See, all of you, we have to prepare a buffer, right, of pH 8.26, right? So if pH is 8.26, can I say POH will be 14 minus pH or 14 minus 8.26? So that will be nearly 0.4, right? 7, right? And 5. So 5.74 is your POH value. Done. Now, for basic buffer, we know that POH equals to pKb plus log of concentration of, please notice here, do not take salt because taking salt is a kind of wrong formula. Concentration of conjugate acid upon concentration of your weak base. So POH we have, it is 5.74. pKb is given, pKb is not given, pKa is given 9.26, but no worries. pKa plus pKb for conjugate acid base, we know that it is again equals to 14, right? So if pK is 9.26, then pKb will be 14 minus 9.26, that means 0.74, right? And 4 plus log concentration of conjugate acid divided by, now the concentration of base here, to prepare a buffer of this, 500 ml of 0.01 molar. So they are adding 0.01 molar of the base. So 0.01. Now using this formula, you can find the concentration of conjugate acid, right? But please remember that for NH4OH, the conjugate acid is what? NH4 plus. So you will be obtaining the concentration of NH4 plus from this, right? But point is, you are getting this NH4 plus from ammonium sulfate, right? And one ammonium sulfate has 2 moles of ammonia, 2 moles of ammonium ion. So suppose from there, if you calculate the concentration of ammonium ion as X, then the concentration of this will be X by 2. Will be X by 2 because one part of ammonium sulfate is giving 2 parts of ammonium ion. So if your ammonium ion is X, then the concentration of ammonium sulfate will be X by 2 here. So that's the catch in this question, right? And that's why I said do not take salt here, because salt gives you, right, wrong result. The actual formula always is a log concentration of conjugate acid by base, or in case of acidic buffer, it is conjugate base upon concentration of acid. So if you do the calculation, you will be getting 0.025 mole, right? After concentration, getting the concentration, you can multiply by 500 ml to find the number of mole, right? Now, can you do this one? So overall, Surya, overall in ionic equilibrium, can I say like this? We get questions from mostly pH calculation, concept of acid base, and sometimes questions of solubility product. But I hope you know that solubility product is a easy topic, right? If solubility is given, you can find KSP, and if KSP is given, you can find the solubility. Now we have a question from the next chapter, redox, right? Don't answer immediately. Let me start the poll. Can you do it, all of you, quickly? What is the oxidation number of oxygen in Na2O2, sodium peroxide? It's a PYQ. It's a PYQ. And it is directly written in the NCERT. Na2O2, the oxidation number of oxygen, right? In Na2O2, it is written in the rules of oxidation number in the NCERT book. Yeah, I can see that many of you are answering D, because D is absolutely correct answer. Yeah, 100% correct. But why only one answer, Canon? I think you all should give the right answer here. See, Na2O2 is very easy, right? For sodium, oxidation state is fixed, right? For sodium, oxidation state is fixed. Sodium has +1 state. So for 2 sodium, the charge will be +2. Now for Na2O2, overall charge should be 0. So for Na2, if charge is +2, so for O2, charge is -2. So for 2 oxygen, if charge is -2, so for 1 oxygen, it will be -2 by 2, that means -1. So oxidation state should be D, that means -1. I hope you know the rules of oxidation number, right? The summation of oxidation number of each atom in a compound is 0, and for ion it is equals to net charge, right? Now, can you do the next one? Okay, we got a question now from the balancing, right? In the reaction, Hi plus HNO3 gives NO plus. Okay, I think something is missing here. NO plus, I think here we have I2. Yeah. So Hi plus HNO3 gives NO plus I2 plus H2O. So what's the value of X? I think you can understand this very well, that HNO3 is an oxidizing agent. Hi is a reducing agent. So HNO3 will convert into NO, right? And iodide ion, it will be oxidized into I2. So this is the redox reaction we have. HNO3 oxidizing agent, Hi reducing agent. HNO3 is having reduction, Hi is having oxidation, but we have to balance it, and we have to answer what's the value of X, Y, what's the coefficient of Hi and HNO3. Please do it. They have not mentioned the medium, right? Because it is self-understood. In the reactant side, we can see we have Hi. Hi is acid. So automatically by default, this reaction will be balanced in acidic medium. Some of you gave the answer D, B. Okay. Surya gave C. Nice. So mixed kind of answer I am getting here. Some answers are B, some answers are C. In balancing, I think if you know the ion electron method of balancing, so that's sufficient for you. Ion electron method is sufficient for you to balance the redox reactions. Okay, so definitely for this question, not B, the answer is C here, right? Oh, many of you gave B as answer. Surya and Kanwan gave the right answer. Answer should be C. Yeah, C is the answer. You know how to do the balancing. Even half balancing is okay here, right? Hi converts to I2, right? So balance the iodine 2, and for 2 iodine the charge is -2 here. For I2 charge is 0. So from -2 to 0 the change in oxidation number is 2. Total change in oxidation number is 2. So we are having loss of 2 electron, right? And for HNO3 it is converting into NO, right? So if it is converting into NO, in the left hand side for nitrogen oxidation number is +5, in the right hand side it is +2. So we are having a gain of 3 electron here, because oxidation number of nitrogen overall it is changing from 5 to 2. So 5 minus 2, total gain of 3 electrons, right? And in the half reaction method, you know that after balancing atoms other than hydrogen, oxygen, after finding out how many electrons are getting lost or gained, you just balance the electron and add it again. So multiply this with 3, multiply this with 2, right? You will obtain 3 into 2, 6 Hi plus 2 into 1, 2 HNO3, right? 3 I2 plus 2 NO. Now, up to this, we have done the half balancing, right? After this, you do the charge balancing, or you do the balancing of hydrogen and oxygen, right? Using H plus and H2O. But we don't need to do that, right? Because we just need the coefficients of Hi and HNO3, which is 6 and 2. So 6 and 2 will be your answer, right? But if you want, you can do the further balancing, right, of hydrogen, oxygen using H plus and H2O. So now let's move ahead. Let's see another question. But this is a question of equivalent mass. Now, point is, yes, Sania, C was the answer in the previous question. Point is, equivalent mass you may have seen in 2 chapters. Either equivalent mass you discuss in the mole concept chapter or in the redox reaction chapter, correct? But anywhere you will be getting questions from equivalent mass. So here we have a question of, we have an oxide which contains 20% oxygen by mass. Then what is the equivalent weight of oxide? What is the equivalent weight of oxide? And mostly you will notice that for the equivalent mass topic, you will be getting questions from either oxide, halide or hydride. Binary compounds, oxide, hydride and halides, these three. So let me start the timer for you. Can you answer this quickly, all of you, within 30 seconds? Nivas is saying B in the chat box. Nivas, please answer by the poll. Paramparik B, okay. Of course, the answer is B. It's a very standard type of problem, right? Like when we explain equivalent mass, so there only we talk about these types of question. See, question is, the equivalent weight of oxide is, now, oxygen is 20%. So let's say that they are saying metal, right? So let's say that this is a general formula of your oxide, MXOY, right? So in this, oxygen is how much? 20%. So metal is how much? 80%, right? So point is, if this is 20 gram in ratio, so this will be 80 gram. Today only I have told you that for any compound, ratio in terms of percentage gram or AMU is same. So if it is 20%, it is 80%. If it is 20 gram, it is 80 gram, right? Now, how we got the metal oxide? By reaction between pure metal and pure oxygen, right? So point is, we can apply law of gram equivalent here. We can apply law of gram equivalent here. What law of gram equivalent says? That when metal oxide will be formed, so the equivalents of metal should be equals to equivalents of oxygen, right? And equivalent or gram equivalent can be calculated by, right, mass upon equivalent mass, right? So equivalents of metal should be equals to equivalents of oxygen for this combination, for the formation of metal oxide. Now equivalent of metal will be mass of metal, which I have 80 gram, divided by equivalent mass of metal, which is E. Now equivalent mass, gram equivalent of oxygen will be mass of oxygen 20 gram divided by equivalent mass of oxygen. I hope for oxygen, you know that equivalent mass is atomic mass by n factor, right? 16 by 2, which is 8, right? So for oxygen, equivalent mass is how much? 8. Now point is, this will be cancelled 4 times and equivalent mass of metal will be 32. But we have not got the answer. This is the equivalent mass of the metal, right? They are asking the equivalent mass of oxide. So point is, for oxide, hydride, halide, for oxide, hydride and halide, right? If you add equivalent mass of your element and oxygen, right, you will get the equivalent mass of whole compound. So I can say like this, that equivalent mass of the metal oxide will be equals to equivalent mass of metal plus equivalent mass of oxygen. And this you can apply not everywhere, but for oxide, hydride and halide, right? For halide, equivalent mass of metal plus equivalent mass of chlorine or halogen. For hydride, equivalent mass of metal plus equivalent mass of hydrogen. For oxide, equivalent mass of metal plus equivalent mass of oxygen. So here equivalent mass of oxygen is metal is 32 and for oxygen it is 8. So 32 plus 8, it will be 40. So 40 should be the answer. B should be the answer, right? But I hope you have understood this point, that for metal oxide, halide, hydride, we can apply law of gram equivalent. From that we can find the equivalent mass of metal or any element. And for oxygen, hydrogen and halogen, you should remember the equivalent mass. For hydrogen, equivalent mass is 1. For oxygen, it is 8. And for halogens like chlorine, the equivalent mass is 35.5. Right? So definitely for this question, the answer is B. So let's move into the next question. So now we have finished almost each and every chapter of 11th, right? So now we are into 12th, right? In 12th, you know that you have chapters like kinetics, electrochemistry and solution. Sania, don't worry, switch the network, right? Yes, Surya, it is 32 plus 8. Well done. So now, can you do this question, all of you? Right? We have a reaction and its expression of rate is given. You know that kinetics starts with rate of reaction, like rate of appearance, rate of disappearance, rate of reaction. You know the relation that rate of a reaction is equals to a rate of appearance or disappearance divided by stoichiometric coefficient, correct? So it's just a analysis based question. So let me start the timer for you. Question is which relations are correct? Out of 1, 2, 3, 4, which relations are correct? Right? So please do this. Out of 1, 2, 3, 4 expression, which expressions are correct? Srija said Nivas A. Okay. Paramparik A. Surya B. Nice. See, in this case, the answer will not be A. I don't know why many of you gave this A. The answer is B, students. The answer is B, right? See, overall, if I write for this reaction, so we have two reactants and we have two products. Point is, for I2, if I write down the rate of disappearance, so that will be minus D concentration of I2 divided by dt, right? And its coefficient is 1. So the same thing will be equals to the rate of reaction. Now if I write it for S2O3 2 minus, so minus D of change in concentration of S2O3 2 minus with respect to time is the rate of disappearance of S2O3 2 minus, right? And if I divide with coefficient 2, so this will be equals to the rate of reaction. So both are rate of reaction, so both are equal. Now for the product S4O6, the rate of appearance will be change in concentration of S4O6 2 minus with respect to time, and here again coefficient is 1, so divide with 1, it will be equals to rate of reaction. So point is, rate of appearance or disappearance you write and you divide that by stoichiometric coefficient, then it will be equals to rate of reaction, right? And rate of reaction is always equal whether you calculate that from reactant or product. Similarly, for I minus, which is a product, so rate of appearance of I minus will be d of I minus upon dt, and here also coefficient is 1, so divide with 1, it will be equals to rate of reaction. Now if you see expression 1, so they are saying minus d of I2 by dt is equals to half of d of S2O3 by dt. This you can directly see from here. That first one is correct. And if you check the fourth one, right, d of S2O6 2 minus by dt, this term, right, and d of I minus by dt, this term, right? So, oh, why we have 2 here? If I equate these two, so it should be equals to 2 times of d minus di minus by dt. So I think here the answer is wrong, right? Surya, you gave B. B should not be the answer. It's a fault in this slide. Correct? Fourth is not correct, right? If I equate these two, I will get S2O3 2 minus equals to twice of d of I minus by dt. So of course here the answer is A, not B. Correct? So a big sorry to all of you, because I said initially that the answer is B, but it's not B, it's A. It's wrongly marked here. So when you get the PDF, because after this session you people will be getting the PDF, right? So please remember this. I am crossing it. This is not the right answer here. Right answer is A. Now, let's move ahead. Okay, talking about the chemical kinetics. Paramparik, if there is S4O6 2 minus, then it is correct. But they have written S2O3, right? So either there is a misprint. But anyways, you people know very well that the logic of the question was about rate of appearance disappearance divided by stoichiometric coefficient gives you the rate of reaction. And from any reactant product, you find the rate of reaction, it should be equal. But we do get question from that topic in the NEET exam. Now, can you do this one? It's a very famous question, right? In kinetics, we do get question from the first order kinetics, especially from the integrated rate law and half-life. Correct? So let me start this poll and let me see how many of you can solve it correctly. Okay, you need more time for this question because there is a calculation of activation energy. This question requires more time. If you want, you can use calculator just for this question. Just for this one, not for the rest of the questions. Many of you gave the answer already. That's so nice. But this question is little bit lengthier side, right? We need a little bit of more time for this. Although the answer is B, of course, right? As expected, none of you gave the answer. But please try to understand what this question says. Answer is B. A first order reaction we have which completes 50%. So first thing is when your reaction is 50% completed, so that is nothing but half-life. When your reaction is 50% completed, so that's your half-life. So point is this 20-minute is nothing but half-life we have. But this half-life is at 27 degrees C. 27 degrees C, if you convert into Kelvin, so 27 plus 273, it will be 300 Kelvin. So point is, at 300 Kelvin, we have the value of half-life, which is 20 minutes, right? Now, for the same reaction, at 47 degrees C, so 47 degrees C is how much? More than 20, means 320 Kelvin. So at 320 Kelvin, for the same reaction, the half-life is 5 minutes. The half-life is 5 minutes. Now you know that for first order reaction, half-life is 0.693 upon K. 0.693 upon K. So from half-life, we can find out the value of rate constant. But we don't have to do that. We need to save our time. So to save our time, what I can do? I can simply find the ratio, correct? I can find the ratio of rate constant at 320 Kelvin to that of rate constant at 300 Kelvin, right? So rate constant at 320 Kelvin will be 0.693 upon half-life at 320 Kelvin, which is how much? 5 minutes. Upon at 300 Kelvin, the rate constant will be 0.693 upon half-life, which is 20 minutes, right? So these two will be cancelled and it will be 20 by 5, that means 4, right? Now after this, you have to apply the Arrhenius equation. I hope you know very well that we have Arrhenius equation which says that ln of K2 by K1, or I think you can start from the fundamental formula if you do not remember that. I hope you know that K is equals to A into e to the power minus EA by RT, right? So this formula if you use, right, from that also you can convert into log form, right? From this I can get log K equals log A minus EA upon 2.303 RT. Right? And the same formula, if you apply 2 times, so once you will be getting log K 320 equals to log A minus EA upon 2.303 R 320, and when you apply at 300, it will be log K 300 equals to log A minus EA upon 2.03 R into 300. Just subtract that, log A will be cancelled. And from that, we obtain this formula, which is basically log K at 320 upon K at 300, it should be equals to EA upon 2.303 R into, right, 1 by 300 minus 1 by 320. If you solve this, you will obtain the EA. But I said initially that you need time here to calculate, correct? Because it will take time to solve 1 by 300 minus 1 by 320, right? Then the values of, anyways, this value is easy. This is 4. So log 4 will be simply log 2 power 2 means 2 into 0.3031. 0.3010 you can write. So this value will be 0.6020, right? So 0.6020 into 2.303 into R value you can put 8.314, and then 300 into 320 upon 20. That much if you calculate, you will get your answer as 55.14. So Surya, we had a huge calculation in this, right, Nivas? But the problem is, we do get question from this formula. We do get question from this formula of calculation of activation energy, and in the NEET exam also, and even in your 12th board, if you see, so in that also we get question from this. And even in exam also, you need to do calculations in this, right? So whenever you get this problem, right, so tell your brain that you need to give time in this calculation in this type of question, correct? But after Arrhenius equation, now let's see the next question we have. If the concentration of the reaction in this 2A plus B gives C plus D is increased by 3-fold, the rate of the reaction will be. So initially we had a question from integrated rate law and Arrhenius equation. Now we have a question from a simple rate law, right? It's very simple. I will not give much time here. Can you do it quickly? Because it's a question you can do it without using your pen paper. In your brain you can solve it. One thing I would like to tell you here that assume this is an elementary reaction. Assume this is elementary reaction because when it is elementary reaction, the stoichiometric coefficient can be taken into the power of concentration term. But if it is a complex reaction, so in that case, it is not necessary that stoichiometric coefficient will be in the power of concentration term in rate law, right? Many of you are giving answer A, and believe me, the answer is A only. Now let me see the leaderboard. Semendemon Surya Canovan, nice, very nice. Of course, it's very simple, right? I said that assume it's an elementary reaction. So if it is elementary reaction, so its rate law will be rate constant into concentration of A power 2, concentration of B power 1, right? So if you increase all the concentrations by 3 times, right? So this will become 3 square and this will become 3 power 1, right? So 3 square is 9 and into 3 is 27. So in this case, the rate will increase by 27 times. But this type of question, although it is easy, but still we get that in our NEET examination, right? So this question and that question of activation energy, right? They don't have any comparison, right? This question has not at all any calculation. And the previous one, where you find the EA from the K1, K2 values, that requires a lot of calculation. So one question takes your time, while the other question saves your time. That's how they frame the questions. Now, can you do this one? Another question we have, and this is again from integrated rate law for the first order kinetics. This time I can give you a little bit of more time. Let's say 60 seconds. Give your answers, all of you, quickly. Nivas, I hope you are not feeling sleepy, right? Sanya? For one thing, I can just salute all of you. You people have great patience. And this I can see only in the doctors, only in the future doctors. Believe me, in my career of teaching of 14 years, 13, 14 years, I have taught JEE kids also and NEET kids also, right? But JEE kids, they can't sit for very much longer durations, right? But NEET kids, they have a great patience. Am I right, Surya? Of course I am. So this time some of the answers are A, but some answers I can see C. Davita, Nivas. For this question, the correct answer is absolutely A, which most of you gave, right? But not in the poll. I don't know why. Maybe due to network issues. Okay. So correct answer is A, of course. And the question says that 99% of a first order reaction completes in 32 minutes. Simply apply the integrated rate law, right? K into T, 32 equals to 2.303 into log. If 99% is completed, means initially if it is 100, the concentration, then after 99% completion, the final amount will be 1, right? So from here, you can obtain the value of K. It will be 2.303 upon 32, log 100 is 2. Now do not calculate it, use it as it is in the next expression. Now, when will 99% of the reaction complete? So again apply integrated rate law, right? Now for 99.9% completion, I can say that K into T, which I have to calculate, will be 2.303 into log. Initially, if it is 100, so after completion of 99.9, it will remain how much? 0.1. Now, K I know. K I have 2.303 into 2 upon 32 into T equals to 2.303 log, and 100 by 0.1 is 1000, right? So now you can see that many terms are getting cancelled here, right? Like 2.303 will be cancelled, right? And from 2 it can be cancelled 16 times, and log 1000 is nothing but 3. So T will be 16 into 3, that means 48 minute, because initially also its unit was minute. So answer will be 48 minute. So I think this type of problems, right? Nivas, Surya, Srija, Sanya, you people can do, right? It's a PYQ. It's a PYQ of NEET exam. This type of problem you will find in your previous year NEET questions. So now, a very interesting and very important question of NEET exam, or NEET for NEET exam for the chemical kinetics chapter. You know that in chemical kinetics we talk about calculation of order, right, for complex reactions. Complex reactions are the ones which happens in multiple steps, right? So we have a reaction here, x2 plus y2 gives 2xy, and it is happening in 3 steps. One is fast, second is slow, third is fast. So you have to find what is the overall order of the reaction. And here only you talk about RDS, right? Rate determining step, correct? So for this, I will not give you much time now. Immediately give your answers, all of you. Option A, B, C or D. RDS is the slow step, right? Why? Because from slow step, whatever rate law we write, so that is applicable for the overall reaction. That is applicable for the overall reaction. Samandiman C, okay. Kanavan C, Surya C. Of course it is C. Of course it is C. It's a very famous question, right? If you have practiced chemical kinetics, then you must have done these types of questions. So I just kept it for your revision. Surya, Sanya, Kanavan, Samandiman, very nice. In 15 seconds, wow. So point is, the second step is slow step. So slow step is called what? RDS, rate determining step. And from second step, right, whatever rate law you will be writing, so that will be applicable to the overall reaction. So in the second step, X is your reactant, Y2 is your reactant. So for second step, rate law will be rate equals to rate constant into concentration of X power 1, concentration of Y2 power 1. But keep in mind one thing, whatever concentration terms you are writing here in the rate law, right, if you apply for the overall reaction, so those terms should present in the overall reaction. Now here, Y2 is there in the overall reaction, but you can't find X. In your overall reaction, apart from Y2, you have X2 and you have XY. So you need to eliminate this X. And how to eliminate this X? Today only we have discussed chemical equilibrium, right? So using equilibrium constant, you can eliminate this X, right? In the first step, which is faster one, for this, if you write the expression of equilibrium constant, that is Kc. So for first reaction, Kc will be concentration of X power 1, concentration of X power 1 upon concentration of X2 power 1. So from here, concentration of X can be given as under root of Kc into concentration of X2 under root or power 1 by 2. So I can substitute this expression as under root of Kc into X2 power half. So now this will be K into under root of Kc. You can multiply these two to create a one constant into concentration of X2, right, power 1 by 2 into concentration of Y2 power 1. Now you can see that in the rate law we have X2 Y2 which is there in the overall reaction. So from the slow step, write down the rate law and just eliminate the term which is not present in the overall reaction through Kc. Right? Now, this is the rate law for our overall reaction where order will be 1 plus half, that means 1.5. So your answer was C, which many of you gave in the chat box, right? But not in the poll. Please answer in the poll, all of you, if you can see that. Now, In kinetics, mostly we get question from Arrhenius equation, integrated rate law for zero order first order, simple rate law, and calculation of order, right? So after kinetics, you have the most important chapter, right? Which is electrochemistry. So now we have some questions from electrochemistry as well. The reduction potential of hydrogen electrode when placed in a buffer solution is found to be 0.413. Then what is the pH of buffer solution? Take your time, but please solve this question, all of you. Sir, your way of speaking is very kind. Everyone is kind, according to me. Especially if you know chemistry, then you will be always kind because chemistry teaches us many things, many things. Very soon, I think on Monday, you will be getting the one shot of Ionic Equilibrium. Please watch that because I have an habit, right? Even in one shot, I try to cover each and every topic. After watching my one shot, the only thing you need to do is practice a little bit of more question. It will be good for you. Now, let me start the timer. Here, I want to give a little bit of more time. So, 60 seconds. Now, give your answers in the poll, right? Not directly in the chat box. There are some chapters, Surya, right? Thermodynamics, Ionic Equilibrium, Electrochemistry. Many of us feel that we are weak in that chapter, but that's not the reality. We are never weak in any chapter. The only thing is our frequency of revision is not correct. Those three chapters which I know, which I said, Ionic Equilibrium, Electrochemistry, and Thermodynamics, you need to revise them very often. Like within 10 to 15 days, at least once you need to go through in those chapters. I got C as most of the answers, and the answer is C. Well done. Like, I'm amazed here. Most of you did it right. Kanavan, Nivas, Inchara, Surya. So what's the point of this question? Of course, answer is C here, 7. The reduction potential of hydrogen electrode when placed in a buffer solution is found to be 0.413. So I hope you know that hydrogen is the standard electrode for you, right? And the general equation for hydrogen electrode in terms of reduction, it is like twice of H plus 2 electron gives hydrogen gas, gives H2 gas. And for hydrogen electrode, if you apply the Nernst equation, you can say that electrode potential equals to standard electrode potential or SRP minus 2.303 RT by NF log Q. But mostly we solve these questions at 298 Kelvin. It is not mentioned in the question, right? It should be given. So at 298 Kelvin, we put it 0.059 upon N log Q, right? Where Q is, right, reaction quotient. Concentration pressure of product upon concentration pressure of reactant raised to the power stoichiometric coefficient. Now in this question, for our hydrogen electrode, the electrode potential is 0.413 volt, right? E naught, I hope you know that for hydrogen, we assume that standard potential of hydrogen electrode is 0, right? And you need to remember that for hydrogen electrode, standard potential is 0. So 0 minus 0.059 upon N. N is the number of moles of electron, which is 2 here. So N is 2 log Q. Q here will be, H2 is a gas. So for gas, I will take pressure. So pressure of H2 power 1 upon electrons mass we ignore, so concentration of H plus power 2 because coefficient is 2. Now they have not mentioned even the pressure. It should be given something like it is 1 atm, right, under standard condition. So pressure you can put 1, and from this expression what you can do, you can find the concentration of H plus. And once you have obtained the concentration of H plus, I think you know that minus log H plus will give you the pH value, and that's what we have to calculate. It will come out 7. I am really weak in electrochemistry. Electrochemistry is an easy chapter, buddy. It has 3 parts, right? One is Nernst equation, in which you calculate electrode potential and EMF, and for both you have the same formula, E equals to E naught minus 0.059 by N log Q, right? And other part is electrolysis, which is very simple. Like either you get numerical questions from Faraday's first law, or questions from product of electrolysis, right? That electrolysis of this electrolyte, what you will be getting at anode, cathode. And then the conductance conductivity part, in which the main formula is R equals to rho L by A. R equals to rho L by A, resistance equals to resistivity into L by A. Revise that once, right? Do some questions, do some PYQs. It will be better for you. Of course, if you want to make anything, right? If you want to improve in anything, of course you will have to apply the effort, right? So of course, in this question, later on, if you calculate pH from the concentration of H plus, you will be getting pH as 7. But in this question, in the question part, temperature and pressure was missing. It should be written in the question itself, 298 Kelvin and 1 atm pressure. Now, can you do this one, all of you? Okay. So we have a reaction or cell reaction here. Cl2 plus 2 bromide gives 2 chloride plus Br2. Now, whatever cell we are constructing according to this reaction, I hope you know that for a spontaneous redox reaction, using a spontaneous redox reaction, we can construct a cell, right? So from this cell, if I construct a cell, so who the EMF of that cell will be, you have to find the standard EMF of the cell is given, and concentrations of chloride, right, bromine, bromide is given 0.01 molar, and for chlorine gas the pressure is given 1 atm. So in this question you can see they have given all the pressure and concentration, right? Same point should have been given in the previous question, especially for the hydrogen gas. The pressure should be mentioned. Corrosion is there or not? Definitely corrosion is there, because corrosion is a redox phenomena, right? Where your metal gets oxidized, oxygen get reduced, right? Metal acts as anode and the oxidized metal acts as cathode. But we have very few points in corrosion. It can be revised in 5 minutes, the corrosion part. So solve this question and give your answers. You can just apply the Nernst equation to get your answer in this. So I am not giving much time. Please give your answers in the poll, A, B, C, D, all of you. I can say that it's a direct question. Welcome back, Sanya. This is a quite direct question, guys, from Nernst equation, calculation of EMF. EMF can be calculated in simple ways, right? First, write the balanced equation. In this question, they have already given you the balanced equation. After writing balanced equation, get the value of N and Q and apply the Nernst equation. That's it. So in this question, definitely, some of you gave the answer. No, the answer is B, right? And how to solve it? It's a very simple question. They have given the balanced equation. So from here, first you get your N and Q value, right? N will be, for any species if you take, like chlorine, its oxidation state is 0 total. And for 2-chloride, the oxidation state is -2. So it is changing from 0 to -2, right? So change in 2, so N is 2 here. Change in oxidation number is nothing but change in electron transfer, number of electron transfer. And if you calculate Q from this, so Q will be concentration of Br2 power 1 into concentration of chloride power 2, coefficient is 2 here, upon concentration of Br minus, right, power 2. And for chlorine, they have mentioned the pressure. So pressure of chlorine power 1. Now point is, all the concentrations are equal, 0.01. So I can simply cancel these two, right, because both have equal concentration. So concentration of Br2, which is 0.01, divided by pressure of Cl2, which is 1. So the value of Q is 0.01, which can be written as 10 power minus 2. Now simply apply the Nernst equation. EMF will be standard EMF, which is given 0.29 minus 0.059 upon N, which is 2, into log Q, which is 10 power minus 2. So now you can see, Surya, how easily we can get our answer. Log 10 power minus 2 can be written as minus 2 log 10. Log 10 is 1. So it will come out 0.29 plus 0.059 upon 2 into 2, right? And nearly the answer will be 0.35 volt, right? Nearly the answer will be 0.35 volts, correct? Now, let's quickly do the next question. Don't worry, all of you. Now I'm not going to take much time of yours, right? We are almost at the end. Currently, we are doing electrochemistry. After this, we will have some questions of solutions. Then we can wind up the session of physical chemistry. But I promise to all of you that within 1-2 days, you will get another session for the organic and inorganic part in a similar fashion. So now, can you answer this, all of you? In the electrolysis, Surya, this is what I was talking about. You get questions of product of electrolysis sometimes from the electrolysis part. So in the electrolysis of aqueous CuBr2 using platinum electrode, using inert electrode, which statement are correct? Okay, let me tell you one thing. I know that in NEET examination, you get single answer correct questions, right? But in this question, there can be more than one correct. So it's a multiple choice question, right? So be careful. It can be A, it can be both AB, it can be all A, B, C, D. In NEET, we don't get multiple choice questions, but I have kept this question because I felt it's a good question. So you need to practice. There can be more than one answers for this. I hope you people are answering in the poll because I can't see the answers in the chat box, right? Okay, see, in this question, it's a very simple question of electrolysis. The answers are A and B, both. A and B, both. None of you gave the answer. I don't know why. Yes, Surya, now you gave the right answer in the chat box. Nivas, A and C. I think there was a lag in network, either from my side or your side. Yes, Srija, not A, C, it's A and B. Let me tell you why. Answer is both A and B. Point is, when you take aqueous solution of CuBr2, all of you, And when you try to decide the product of electrolysis, so do like this. First, you write down whatever ions are available in your solution. So if I take aqueous CuBr2, I will have H plus ion from water. I will have OH minus ion from water. I will have Cu2 plus ion from CuBr2. I will have Br minus ion from the CuBr2. Now, during electrolysis, we know that cations will go through reduction at cathode. So we have two cations, H plus and Cu2 plus. So out of these two cations, when I use inert electrode, which cation will be reduced is decided by your electrochemical series according to the value of SRP. The one which has a more SRP value, right? It has more chance of getting reduced, right? So please memorize the electrochemical series, right? We have so many tricks for that, correct? We have so many tricks for electrochemical series. Please remember that because it will help you here in order to decide which cation will be reduced. So out of H plus and copper 2 plus has a higher SRP value. So copper 2 plus will be reduced, right? And copper 2 plus will be reduced by accepting 2 electrons into solid copper, and reduction happens at cathode, right? Now, out of anion, OH minus Br minus anion will be oxidized, and even for anion you decide it with electrochemical series, but for anion you can use a trick from my side. The trick is, out of multiple anions, the anion which has less number of atom, that you can suppose that it will oxidize. Like OH minus has 2 atom, oxygen, hydrogen. Bromide has only 1 atom, bromine, right? So the one with lower number of atoms will be oxidizing, will oxidize here. So out of OH minus, Br minus will oxidize, and Br minus will oxidize to give you Br2 by loss of 2 electron, and oxidation happens at anode. So option A is Br2 is evolved at anode, correct? Copper is deposited at cathode, correct, right? Br2 evolved at anode and H2 gas at cathode. H2 is wrong here, right? And H2 gas can't be deposited because here copper is getting deposited, right? So please remember electrochemical series, and the trick I have said that less number of atom containing an ion will be oxidized first. That will easily give you, right, the answers in the product of electrolysis. Now, let's quickly move ahead, right? Can you do this question again from electrolysis? We saw question from Nernst equation. Now we are looking into questions of electrolysis, right? So we saw a question from product of electrolysis. Now we have a question from Faraday's first law, right? Faraday's first law, weight deposited is directly proportional to amount of electricity. W equals to A upon NF into Q, or A upon NF into I into T. So that formula you need to use here. Can you solve it a little bit quickly, all of you? I have started the poll, right? Okay, wait. Even this question, let me start the poll again. Why? Because even this question is multiple correct. We have multiple answers in this. Now you give the answers, all of you. I hope the options are visible. Yeah. A current of 2.68 ampere is passed for 1 hour through aqueous solution of copper sulfate using copper electrode. Select the correct statements from the following. When you do electrolysis of copper sulfate, please remember that at cathode, copper 2 plus will deposit, but at anode, anion will not deposit. Instead of that, anode will decompose, right? And that's why this method of electrolysis we use for the purification of copper. Right? So even for this question, right, the answers are same, A and B. None of you gave the right answer again. See, this is a very simple question. When you supply 2.68 ampere current, right, for 1 hour, so 1 hour means 60 minute into 60 second, right, through aqueous solution of CuSO4. Point is, when you take copper sulfate and you use copper electrode at both anode cathode, so at cathode, copper 2 plus will deposit into copper, solid copper, and at anode, the copper will decompose into copper 2 plus, like this. So at cathode, if you try to calculate how much copper is getting deposited, so for that you can apply the formula from Faraday's first law, W equals to A upon NF. So for copper, atomic mass is 63.5, N here is 2, F you know it is 96500, and Q is written as IT, so I is 2.68, and time is how much? 3600 second. So if you calculate it, you will get it 3.174 gram. But the point is, at cathode, because copper is getting deposited, so at cathode, you will have gain of this mass. But at the same time, you will have a decrease in mass at anode because, right, same amount of mass at anode, it will decompose into your solution. Correct? So I hope you people know this because it's one of the exceptional case we have in the product of electrolysis. We have 3 exceptional case in product of electrolysis. One is electrolysis of concentrated H2SO4. Other one is electrolysis of aqueous NaCl using mercury cathode. And the third one is this, electrolysis of copper sulfate using copper electrode instead of inert electrode. Right? In these 3 cases, the products are not strictly according to the electrochemical series. So these 3 cases you need to remember. Right? Now, can you solve this question? So we saw question from EMF, we saw question from electrolysis, and now we have a question from the Surya. Last part, that is conductance conductivity. And we do get question from this also. We have the resistance of 0.5 molar solution of an electrolyte in a cell, right? And resistance is 50. If the electrode in the cell are 2.2 centimeter apart, so L is 2.2, area is 4.4, so L by A we have, cell constant we have, then the molar conductivity we have to find. So first we will be calculating conductivity, and from conductivity we can find molar conductivity. Please do this quickly. A little bit of more time here. I want answers now from all of you. Please participate. Nivas. Only 5 or 10 minutes more I will take. Sania, Kenavan, Nivas, Surya, are you people there? The only catch in this question is mostly when we calculate molar conductivity, so we get that in the units of Simon centimeter square per mole. So in this question also you will calculate molar conductivity in terms of Simon centimeter square per mole, but later on you need to convert that centimeter square into meter square. To convert centimeter square into meter square, you can divide with 10 power 4. You can divide with 10 power 4. C, right? I think all of you have answered C in this case. And C is the right answer. Well done, all of you. Well done. Very nice, Kenavan, Sanya, Nivas, Surya. So the question is very simple here, right? First, you need the conductivity, right? Conductivity, right? If you forget the formula of conductivity, just remember this: R equals to rho L by A, right? Interchange R and rho, like put R into RHS, rho into LHS, it will be 1 by rho equals to 1 by R times L by A. Now 1 by rho is nothing but your conductivity. So conductivity is 1 upon resistance times cell constant. So 1 upon resistance is given 50 ohm. So 50. Length of the distance between the electrode is 2.2 and area of cross section is 4.4, right? So this will be cancelled 2 times. It will come out 1 upon 100. Keep it as it is, or you can write it as 10 power minus 2. So this is your conductivity, and the unit of conductivity here, it will be Simon, right? Centimeter inverse, because these are in centimeters, correct? Now, from this, you can directly find out molar conductivity. Molar conductivity is conductivity upon molarity into 1000. But remember, from this formula, conductivity you obtain, it will be in the units of Simon centimeter square per mole. So, conductivity is 10 power minus 2, right, into 1000. Upon molarity, it is given 0.5, right? So, 1000 into 10 power minus 2 will be 10. 10 upon 0.5, right? So it will come out how much? 20. But the unit here from this formula is Simon centimeter square per mole. Normally we obtain in the same unit, Simon centimeter square per mole. But in this question they are asking in Simon meter square per mole. So to do that, convert centimeter square into meter square, and for that you divide with 10,000. So it will come out 0.020 Simon meter square per mole, and that's why your answer will be B. No B, it's C. I think I did mistake in dividing, right, Surya? Yes. It will be 20 upon 10,000. So 0 cancelled. 0.2, 0.02, 0.002. Okay. 0.002 will be the answer. Simon meter square per mole. So I think in the conductivity part, conductance part, you need to remember R equals to rho L by A, right? Conductance is 1 by R, 1 by resistance. Conductivity is 1 by rho, 1 by resistivity. Molar conductivity is conductivity upon molarity into 1000, and from that you get molar conductivity in units of Simon centimeter square per mole. And one more term we have, that is equivalent conductivity. So equivalent conductivity is conductivity upon normality into 1000, right? Now, the last phase of today's session, right? Or you can say the last chapter for us for the NEET examination, solution. But I hope you know that solution is a easy chapter, right? Amit, Srija, solution is easy, right? I feel solution is a free chapter for us. Can you answer this quickly, all of you? Which of the following will not form non-ideal solution? So if it will not form non-ideal solution, so why they have framed like this? It can be simply written like, which of the following is ideal solution, right? Which of the following is ideal solution? Can you answer quickly within 30 seconds, all of you? Ethanol, water, nitric acid, water, chloroform, acetone, and benzene toluene. Out of these combinations, in which case we have ideal solution? Surya, we are almost done. Just 5 minutes. So definitely in this case, the answer will be D, and it is given in your NCERT also. I don't know why some of you marked A, right? Ideal solution is toluene plus benzene. It's a very standard example of ideal solution, right? Anyways, ethanol water, it shows positive deviation, right? It's an example of non-ideal positive deviation solution, right? HNO3 and water shows negative deviation, right? So benzene and toluene, right? It's a mixture which can form nearly ideal solution. So that's why answer is D in this question. Now let's move ahead. Can you solve this question? At certain hill station, the water boils at 99.725 degrees. So this is the boiling point of water. If Kb for water is 0.513, right? The boiling point of 0.69 molar solution of urea. Let me give you 45 seconds in this. So it's a question of, you can clearly understand colligative property, right? It's a question of colligative property. In colligative property, from the elevation of boiling point, where you have formula like delta TB equals to Van't factor into Kb into molality, right? Same kind of formula we have in depression and freezing point, delta TF equals to Van't factor into Kf into molality, right? The vapor pressure part is different, P naught minus P upon P naught equals to mole fraction of solute. Then osmotic pressure is also different. Osmotic pressure is Van't factor into molarity into R into T. Many of you saying that answer is D in this case. D. Not predictable. It is predictable. And the answer is none other than A. I think Surya gave it right. Answer is definitely A. 100 point. And it's an easy question. Of course, if the pure water boils at 99.725, so after dissolving non-volatile solute, its boiling point will increase because we have elevation in boiling point. So it should be greater than 99.725. Now, how much elevation will happen? You can find it from delta TB as I Kb molality, right? If in your question they have not mentioned regarding your solute, which is your solute, assume Van't factor to be 1. If solute is given, the nature of solute is given, then calculate the Van't factor and put the value of Van't factor. So in this question, they have not mentioned the solute. Okay, they have mentioned it, right? Urea. So urea, sucrose, sugar, they are the compounds which will not dissociate, associate, right? So for those compounds also, Van't factor is 1. So Van't factor will be 1 here. Kb is given 0.513. Molality is given 0.69. Multiply this, you will get your delta TB, and finally the boiling point of solution will be boiling point of pure water, which is 99.725 plus whatever delta TB you are getting, right? This is the elevation in boiling point. So if you solve that, you will get nearly 100.08 as your answer. Not 100.03, it is coming 100.08 nearly. Surya. It's not 100.3, it's 100.0 something. Do you want me to multiply this? Okay, 0.69, I can take roughly 0.7. So 7 3s are 1, 2, 7 1s are 7, 2, 9, 7 5s are 35, right? 1, 2, 3, 4, 1, 2, 3, 4. It is 0.359. Round off, we can take 0.36. Right? So 99.725 plus 0.36, it will come out nearly 5, 2 plus 6, 8, 7 plus 3, 10, and 99 plus 100. So for me, I am getting 100.085 because I did little bit of round off. So I am getting 100.085. The answer is 100.079. Quite okay, right? Canoan, it's not 100.03, it's 100.08. I did the calculation here for you. Okay, let's move ahead now. Okay, so we have a logical question here, and it is from the property of liquid. Like we start the chapter from the knowledge that what properties liquid have, right? Like boiling point, vapor pressure, surface tension, all those things. Question is, among the following substance, the lowest vapor pressure is exerted by. So vapor pressure is related to the intermolecular force, right? If your liquid has more intermolecular force, then it will have low vapor pressure. If your molecule has less intermolecular force, then it can be easily vaporized. Low intermolecular force means it can easily vaporized. So it will form more vapor at lower temperature. So directly give your answers, all of you, for this question, that out of water, mercury, kerosene, rectified spirit, in which case we will obtain lowest vapor pressure at same temperature. At same temperature, if I take water, mercury, kerosene, rectified spirit, so in which case I will be getting lowest vapor pressure. B, of course B, fantastic. So this point is very common. 100% correct answers. Surya, Kenovan and Sania, very good. So point is, lowest vapor pressure we will be getting in the case when we have lowest vapor pressure we will be getting when we have highest intermolecular force. So water has hydrogen bond, right? Mercury has metallic bond. Kerosene has non-polar, means induced dipole bond. And rectified spirit has weak hydrogen bond, right? Hydrogen bond but weaker than water. So I think metallic bond is very strong, right? Metallic bond has no comparison with intermolecular force, van der Waals force, hydrogen bond, right? So because mercury has metallic bond which is very strong, so it will have the lowest vapor pressure, right? So definitely in this case answer will be mercury. Now let's move ahead. Let us see the next question. A 5% solution of cane sugar is isotonic. So again we have a question from colligative property, but this time from osmotic pressure, right? And in the osmotic pressure part, I hope in bio you have much more terms, right? In bio you talk about isotonic, hypertonic, hypotonic. In chemistry we mostly talk about isotonic, right? Isotonic means those solutions which have same osmotic pressure, right? So a 5% solution of cane sugar is isotonic with 0.877% of X or 0.877% solution of X, then the molecular weight of substance X is, please solve it. I will give you more time for this question, nearly 45 seconds. Start giving your answers by calculating it, all of you. After this, you have only one more question left. Then we will end this session for you. Surya said A. Of course, the answer is A. Of course, the answer is A here. But you didn't answer in the poll. Why? You need to answer in the poll. See, isotonic means what? The osmotic pressure of the sugar solution should be equals to osmotic pressure of whatever X you have, right? Now, osmotic pressure is Van 't Hoff factor into molarity into R into T, right? So Van 't Hoff factor for sugar is 1 and X is unknown. So for them also I can take Van 't Hoff factor 1. RT will be cancelled. Molarity into RT. So I is 1, RT for both sides it will be cancelled for the same condition. The only thing we have to equate here is the concentration value, right? And concentration here, I can say it will be number of moles per unit volume, correct? So cane sugar, if it is 5% solution, so that means sugar is 5 gram there, right? And for sugar, formula is C12H22O11. If you calculate its molar mass, I do remember it. So if you calculate the molecular mass, it will come out 342. For glucose, it is 180 and for sucrose, it is 342. So 342, right? and if it is 0.877%, means if it is 0.877 gram, right, then divided by, let us say its molar mass is x. So this x you have to find. How much you are getting? Anyone has calculated it? Srija? 59.9. This will be cancelled like 5 6 30 and 5 8 40.4. So 68.4 into 0.877, it will be nearly 60. And near to 60, I can see only one option. So I think here your answer can vary a little bit. It can be 59, 58 or 59, right? But the nearest answer will be A here. Yeah, 58.98. How many of you got 58 or 59 as your answer? Srija got, Sania got, Surya, your answer? Kanavan answered A already. Okay, now for all of you, the last question for this session. And I want answers from each one of you this time in the poll itself. Again, it's a question of yeah, the answer is not absolutely exact value is not there. The answer is 58.98. So it can be vary between 58 to 60 range when you calculate 59.98. So I can say that it is near about answer. In your PDF, you will understand. Now, can you solve this? I will give you enough time for this question. Let me give you 90 seconds for this. But I want answers from each one of you this time. The freezing point of aqueous solution of non-electrolyte. Non-electrolyte means Van't factor will be 1, right? Freezing point is given minus 0.14 and it is aqueous solution. So for aqueous, for water, freezing point is 0 degree. So minus 0.14 is freezing point. That means delta TF will be 0.14, right? The molarity of the solution is not molarity. You have to calculate molality. You can see the options, right? In options, it is given molality. In the question, by mistake, it is written as molarity. So you have to find molality, not molarity. Molality. But I want answers from all of you. I hope that this session will help you a little bit, like in a way of revision, right? I didn't just solve the question. Along with questions, for each questions, I tried to explain the concept. And for each chapter, at least I told you that what topics you should cover in this session. That much I have done, right? So some of you said C and many of you are saying D. D is the right answer in this. D is the absolutely correct answer, right? Kenavan, Srija, Sanya, Surya, well done. The question is quite direct. I told you already that if freezing point is minus 0.14 for water, that means it has been depressed by 0.14. So delta TF is 0.14 here. And delta TF can be written as I. I is 1 because it is non-electrolyte into Kf. Kf is 1.86 into molality. So it's a direct question, right? Molality will come out how much? 0.14 upon 1.86. So if you calculate this, right, you will get your answer as D. Of course, it should be smaller, right? Much smaller. And the smallest answer here is D, 0.075. Correct? So that's it in this session. And in this session, what I have tried, to discuss. I tried to cover the whole physical chemistry for you, all the chapters that we have in the NEET exam. I tried to cover all the important topics, questions from that. Now, still, see, you can't say that you are done with your preparation, right? I gave you a revision in this session about your physical chemistry. Now, if you want, you can solve more questions from each and every chapter. Of course, there are chapters from which you don't need much practice, like you don't have to solve questions from the mole concept chapter or the atomic structure chapter. But you need to solve more questions from electrochemistry, from the kinetics, from the thermodynamics, from the ionic equilibrium, right? So, according to your current preparation, you will have to decide by your own, right? That in which part you have to focus more. So thank you so much, right? In this session, we are done. But homework, you have to practice more questions. You have to revise concepts. If you don't know, watch the one shots, whatever available, right? And we will meet now in the same way, right? In the next marathon in 1 or 2 days, right? To discuss the organic and inorganic chemistry questions. So thank you so much. Over and out. Bye-bye. Me too, Surya. Bye, Kanavan. Bye, Sanya. Bye, Srija. Bye, everyone.